Yo, what up, chat? What's up, guys? How's it going? Hello, hello. Yo, thank you for that, out of the gate hype train. thank you, Zummy, for the 35 months. User, what's up? Right Joy-Con, hello, hello. Excuse me. Yo, Right Joy-Con, thank you for the 11 months as well, dude. The tier 3 11 months, by the way, man. Thank you so much for the tier 3 11 months. Satis, how's it going? Hello, Cryophonic. What's up, man? How's it going? What's up, everybody? How we doing? Sorry, I swallowed my drink wrong and I was like choking. But yeah, so today is going to be a very interesting stream, mainly because I'm really trying to understand how I can effectively develop Quirk and where my problems really lie. One of the things that I've noticed with Quirk is that as it evolves and changes, I have to make sure that I'm building tools or, opportunities for me to want to keep building it. When I moved everything to Azure, I broke the entire local development flow. Now there is an article on the internet. Hold on one second. So there is an article on the internet under technical design documents that I made called Hybrid Feature Environments. And it's actually, it actually does a pretty good job of, that's not what I wanted. It actually does a pretty good job. There we go. Of explaining what the concept is. But the TLDR on it is that we want to be able to have a dev environment that exists in the cloud that is always there. And whenever we merge a change to the, the master branch or whatever, then that goes to that dev environment or this, whatever this environment is that we can work against. And then this environment will also be an environment that we can use locally with it. And the whole concept is if I wanted to, for example, say work on the API service, but I didn't want to have to deploy the whole stack, I could deploy the API service locally or write and work on the API service locally, and then push my changes up to the cloud once I'm done. And again, the nice part of that is that Quirk can then continue to scale at a very, 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 very large, rate in the sense of microservices and stuff, but we don't have to worry about having all of those services locally for things like development and whatever testing. So yeah, that's kind of what this concept of hybrid feature environments do does. And so we're gonna try tackling that today. But I've already tried this approach once before, and this might be something for anyone who's tuned in before. You might be like, oh, well, you've done this already. I have. So I realize now that there was two parts to the problem, and I didn't fully see it. The first part of the problem was just figuring out how to do the routing and all of the stuff that is really mentioned in this article. And this helps me make it so that it's possible to achieve hybrid feature environments, right? But it doesn't actually take it as far as how do we actually achieve it in a way that makes sense. And so when I first wrote this all up, I was like, all right, well, I'll just use Docker Compose locally. And I'll use, environment variables and stuff like that to run the container locally. And so I'll use Docker Compose locally, and then I'll use, Kubernetes in the cloud. Well, the problem with that I ran into is that Docker Compose does have some really cool options in the sense of you can use .m files or inject secrets and stuff like that. But I don't really want to change how my application receives its secret values, right? So for example, if I'm deploying something into Kubernetes and I'm using a secret that exists in an environment variable, then I want to make sure that that environment variable and that value is delivered the same to that container no matter what. And so this was a problem with Docker Compose, mostly around certificates, and how certificates are read with environment variables and things like .m files and that kind of setup. And so the problem is that the certificates, the private key and the public key, were not being read properly by Docker Compose via the .env. I used it in a .env. I used it directly in the Compose file itself. I used it a bunch of different ways to trying to get it to work. And again, I don't want to sacrifice what exactly I'm trying to achieve, which is, making sure that it's consistent. It's something that's, reproducible. And so, using Docker Compose really didn't stack up the way I needed it to, in the sense of like, okay, I need to be able to, excuse me, run this service the way it would be ran in the cloud, but then develop against it. So today, we're going to talk about something that I thought about more and more of making it, I think, more realistic for local development. And I think a tool that we're going to be leaning on today will help with it, which is if you're in the cloud and say, for example, you're running something very simple like a container, then you really don't need to worry too much about what container orchestrator you're using. But if it's a circumstance where you have kind of a more opinionated setup, or you have a very specific DSL around your services, local development might have specific requirements that we need to meet if we want to run them locally. And it's more so about fitting within the design. Excuse me. It's more about fitting within the design that's intended, and then stepping out rather than stepping outside of it and making something that just works, right? And when I thought about it, I do know that Kubernetes has become more and more as a common thing for local development. I've used it a few times already. But again, the goal here should be, I just want to run a command to do this. I don't want to have to, do a bunch of different deploying and things like that. However, if I was able to use Kubernetes in a similar approach that I could with Docker Compose, like if you think about that for a second, like, okay, I want to actually, be able to interface with Kubernetes as easily, up, down, start, stop, stuff like that, restart, whatever. What would that workflow look like? And so today, that's what we're going to build out, essentially. We're going to try building out a workflow that works for one of the services. And then we're going to document it. We'll put it on the wiki, like always. And, that'll give you an opportunity to take a look at it and see if this is something that you're interested in doing too. But the whole idea here, again, is saying, okay, Docker's really not our orchestrator anymore. It's not really our container runtime. It's not the thing that's actually running those containers. It's Kubernetes. How could we run Kubernetes locally, but also make it really easy to run, say, again, a service with like a bunch of secrets or a bunch of configurations or something like that. We really don't want it to be challenging, right? We want it to be something simple. Using Kubernetes for local hobby projects in what way? So no, this would be using it for an application that we're building. This would be using Kubernetes locally for developing the app we've been developing now for a while called Quirk. So the idea would be having that runtime locally, and then again, running those services with that runtime locally. Okay, so I've gone ahead and actually started an article that I will again upload to the wiki once we're done here. But it's really going to kind of outline, what the problem is, as well as what we're trying to achieve, or what our goal is here. Now, like I said, by the title, we really want to do local development with Kubernetes, right? And we want to be able to make it so that it's a consistent way of doing it, right? So that if I pull a repository on one computer or another, I don't have to worry about managing a bunch of different configuration files. I don't have to worry about saying like, oh, okay, like, does this have this configuration in it? Or, oh, okay, does this have this configuration in it? It should be something that's very, straightforward. It should be something that's, again, very easy, and sane a sense to manage. And yeah, the idea that first came to my mind was okay, let's use a type of automation tool. And in the original problem here, I'm actually saying Pulumi right out the gate, but I'm going to remove this because I don't want heavy opinionation yet. And so we're going to say, we'll say automation. Oh, wait, no, my bad. This is a fact. My bad. This is actually saying, no. Okay, so we don't need to change this. My bad. This is actually saying Pulumi is used to automate all of our deployments of Kubernetes to cloud environments is what we'll say. And that's it. That's really the problem, right? We need a way of running local services and doing local development consistently. And the only other thing that we can really add to this is that Pulumi is something that we use to automate all of our other services. We could really remove this if we wanted to and say like existing setup, right? Pulumi is used to automate all of our deployments to Kubernetes in cloud environments. Pulumi maintains all of the service configurations and secrets in encrypted values. These are shared in the repository via encrypted files. So essentially, the current setup is we use Pulumi in the cloud to deploy all of our Kubernetes deployments. And Pulumi, because we like how Pulumi does a lot of the things that it does, Pulumi maintains all of the service configurations and secrets in encrypted values. And then these are shared in the repository via encrypted files. Now, I guess it doesn't really need this part here, but we could say these encrypted ENCR, wow, I cannot spell, encrypted values are stored in the repository, then decrypted at runtime. Cool. Okay, so that's the existing setup. There is no existing setup for local development as that was broken with the migration to Azure. This was a desired step to rethink the development process after the migration completed. So that's the thing to note is like I did this purposely. I did do this in the sense that I knew that I would be breaking this and wanting to fix it later. So yeah, that's just, again, something to note. Having to run Kubernetes locally at work sucks so bad. Macs were consistently overheating. Glad we have some remote test boxes now. Yeah, I mean, so don't get me wrong. You could do this in the cloud as well if you wanted to, right? Where it's running, I guess, in the sense of what local means is really up to you. I'm going to be doing this locally on my computer just because my machine should be able to handle it, hopefully. But yeah, I can definitely, I've definitely seen, I've had MacBooks before that have sounded like turbines with all the containers running. We'll say production. And then this is development, existing setup. Okay, cool. Below outlines the existing setups we have for each environment. Okay, cool. All right, so we know what our problem is, and we know that we use Pulumi in production, and locally we have no existing setup. What we can also say is there was investigation around using Docker Compose for local development. However, this was not a viable solution due to how Kubernetes injects secrets via environment variables, and Docker uses its native secrets abstraction. So if you don't know what this means, essentially Docker decided, hey, yeah, environment variables are nice, but like they're really insecure, and so we're going to create our own mechanism to support secrets. And so if you've ever used Docker Compose or Docker Swarm or anything like that, then you probably know about Docker secrets. And they're a neat concept. The whole idea behind them is essentially that a secret is read from an encrypted database, essentially, and then that secret is mounted to the container via a temporary FS mount. And what that really means is that there's memory allocated directly to the container. It's not something that ever exists on the machine itself. It's something that allows you to allocate memory as a volume, essentially, to a container. And then that is something that you can read via a file, right? Or whatever, it really would just be via a file, but however your app decides to read that file. And so Kubernetes is you can do both if you wanted to. You could mount secrets as files, and you could mount kind of vice versa, I guess, if you wanted. But the main idea is that mostly it's through environment variables, right? Config map or secrets. And so because that's just how we've chosen to do things, as well as just other opinionations around the deployment too, they don't translate well from one to another. As well as, like, for example, like the way that Pulumi manages those configuration values and how it's able to then ship that between repositories because it's encrypted and stored in the repo, instead of me saying like, okay, you have to have an environment variable here that you have to create, and then you have to have an environment file, or I'm sorry, not environment variable, you have to have an environment file here that you have to create, and then you need one here, right? Like Pulumi kind of handles all of that for us, which again is really nice. So this is what makes Pulumi really attractive to do local development with Pulumi, because it's checking off a lot of the boxes that Docker Compose can get close to, right? And I feel like that's something we all deal with a lot, which is like Docker Compose can get close to it, but it doesn't necessarily like get all the way, and so this is kind of us seeing like, can we go all the way? Can we get a fully running Kubernetes setup and, basically have our cake and eat it too? What's up, OT? How's it going? Hello. Okay, so again, we know about our production setup and we know about our existing development setup. So let's talk a little bit about what do we need, right? Each service uses environment variables to provide configuration and secrets to the container at runtime. This was a decision made to allow Pulumi in production, in cloud environments to be the configuration and secrets manager. Somehow the channel was recommended on Twitch, and I was like, uh-oh. Nice. Well, hey, at least you got here no matter what, I guess. The algorithm still got you. Okay, cool. So each service uses environment variables to provide configuration and secrets to the container at runtime. So TLDR, we use environment variables for everything. This decision was made to allow Pulumi in cloud environments to be the configuration and secrets manager, which is what it is. Whenever we want to change a configuration to something, we use Pulumi to do that. And so this is, something that would be desired, is to have something that manages these things for us rather than, like I said, having a .m file that has to be like copied around or, you know, managed in some other weird way. So we need something that provides, so we'll say something that provides environment variables to the container at runtime. And we should say this should be able to store configuration and secrets values. This should be able to store configurations and secret values. Yeah. So we need to provide environment variables to the container at runtime, and then we need to be able to store the configuration and secret values somewhere, right? I'm doing good. Okay, cool. So what else do we need outside of things related to the configuration and the secrets, right? Like those are the things that are going to be the things that, I guess like make it sure that the container starts, right? But like what else outside of that maybe, you know, doesn't necessarily stop the container from starting, but might be other things that we need too. And there is actually a way we could do that. We can go to service quirk, and in this repository, this is our actual automation. So for example, if I wanted to, I could go to API and see all of the existing Pulumi automation for what is there. And so again, we've already got environment variables, and then the ability of you know, storing those in config maps and secrets. So those are those first two lines. We have a service, right? Now the service is used to expose the running container in the Kubernetes cluster to other services in the Kubernetes cluster. So I guess the first question we have to ask ourselves is that something we need? Our Kubernetes cluster should not be necessarily accessing other services. And that kind of asks or begs the question, are we going to be developing multiple services simultaneously? And I think the unavoidable question is that yes, we will actually be doing that. There will be scenarios where I'm going to have to be building, you know, something in the front end while simultaneously being able to, you know, modify the back end. And it's really not super effective for me to only be working on one thing at a time. Now, does that mean like I need a whole local deployment per se? Not really, but it does beg the argument we could get close to it, right? So I guess we have to ask ourselves the question again, how far do we want to get and how isolated do we want to get? Within the scope of just saying the API service itself, we really don't need to be worried about services at all. But again, if I was, for example, to say, okay, I want to also develop the WebSocket service, then I should be able to do that as well in the same Kubernetes cluster. And we don't want to have to create another Kubernetes cluster just to be able to develop the other service. So it doesn't make sense for us to have multiple Kubernetes clusters, one, and two, it does make sense for us to run multiple services in one Kubernetes cluster if we need multi-development or multi-service development. So what's up, Agent Orange? How's it going, buddy? And Windward Hive. Hello. So yeah, so I guess thinking about that, if we say that we want to be able to do multiple, services, then we also need to say that we need to have everything that those services need, right? Now, there is another document in the wiki under technical design documents called Pulumi project repositories. If you guys are interested in this one, you can check out this as well. From where do you read the image pull offline in line 9 and it is that encrypted? Give me 1 second and I'll show it to you. Yeah, dude, I totally want to buy followers. That's awesome. But if you look at that article, Pulumi project repositories, you can see that we have these 2 separate automation repositories that manage different aspects of the stack, essentially. The first tier is kind of the cluster tier, and this is like the SaaS stuff where like I need a load balancer that everything can access. I need an ingress controller and Knative and like, these other things. And then there's the service tier where we're talking about like, okay, I need Postgres, Redis, API, whatever. If I wanted to, for example, make it so that I could have services in my Kubernetes cluster be accessible outside of it, I would really want an ingress controller or something similar. Like I'd want to mimic the approach that I'm basically taking in the cloud. And to do that, that means that there will be more resources that will be required to be provisioned in the Kubernetes cluster, which means that we now need to kind of think about just how the automation is isolated, right? Because we also don't want to find ourselves in a circumstance where like this deployment works this one specific way here versus this one deployment works one way here, right? We really want to make it so that we can easily deploy these services kind of anywhere. So yeah, that's something to consider too. Ideally, or I guess not ideally, but realistically, if we wanted to, we would need to run the whole cluster automation against the repository, which is fine. If we go look at the cluster repository automation, so we'll just go to cluster quirk. Late stream, yeah, I just needed to work on some stuff, so it was a good opportunity. So if we go to this repository, cluster quirk, here, I'll show you guys, I'll give you guys a little bit more space to see stuff here. If we go to this repository here, we will see that in it, if we go to resource, there's 5 resources: Azure DevOps Agent, Ingress Nginx, Keel, Knative, and Metal LB. These are the low-level resources that really any quirk cluster requires to be able to run quirk services. It's not too crazy, right? It's not too complicated, but it does mean that if I wanted to do like webhook work or cloud function work, I would need Knative, right? If I wanted to be able to access these things outside of the cluster, I would need Metal LB and I would need Ingress Nginx. Now, I wouldn't need the Azure DevOps agent. That's something I don't need, right? But I would need some of these things. So I guess it is something to note that multi-service development support for we'll just say multi-development support. And so to add on to this, we'll say in the situation, or we'll say when 2 services need to be worked on simultaneously. I cannot spell. Oh my gosh. Hey, I spelled it right. When 2 services need to be worked on simultaneously, these can be deployed to the same Kubernetes cluster. So that's the first thing. The second thing is that these services can also be configured to point to each other in the local Kubernetes environment, and then to the cloud for non-local services, right? So the whole idea is that in the first one, when they're being worked on simultaneously, they can exist in the same local Kubernetes cluster, and we'll put local here just to be 100% clear. right? So that's the first thing that we need to do to be able to support multi-service development, right? They both need to be able to deploy locally. The second thing is that those services need to be configured so that they can point to each other locally when they're developed on, but then when they are those services don't exist locally, they need to have those services then be pointed to in the cloud. So for example, if I'm working on the API service and the WebSocket service, right, locally, then the API service and the WebSocket service should be, pointed to each other in the current Kubernetes cluster, the one that's on my host, right? But any other service that is not should be able to not just, point to those services in the cloud, but also be able to synchronize with those services in the cloud, right? They should be able to have all the same credentials and all of those other things too. So it is going to be very important for us to have a good secrets manager, because to be able to do that really easily is challenging. So multi-service local development support. So when two services need to be worked on simultaneously, these can be deployed to the same Kubernetes cluster or the same local Kubernetes cluster. They can also be configured. They can also be configured to point to each other in the local Kubernetes environment, or we'll say cluster, and to the cloud for non-local services. Yeah. So you're asking, is that a Pulumi stack? Not yet. This is just a documentation. What's on the right is Pulumi. Yes, what's on the right is Pulumi. Okay, so what else do we need? So we've talked about providing environment variables, storing configurations, and then multi-service support. One last thing with multi-service support is if we decide to support multiple services in development, which we probably will, then the cluster quirk automation will also need to be run locally for required services. And these are things like knative, ingress controller, etc. Right? Nothing too crazy, but that is the other thing we need to note. So again, for multi-service local development support, we have these things here. Okay, cool. So we've talked about working with multiple services. We've talked about configuration. We've talked about the environment variables. Let's talk a bit about something that is unique between the two environments, right? And that's going to really be the image. In the cloud, we are going to have a production image, right? In the cloud, we'll have a production image of some sort that's built, and ready to go and ready to run, right? Compressed, whatever. Locally, however, we have no image whatsoever. What we do have is the actual raw files, right? And some way to probably run it locally. That could be TS Node if you're using TypeScript and you're doing development locally. It could be Go Run if you're using Go, right? But Python would be like Python and then the file. But the main idea here is that you run the application locally when you're developing it differently than you run it in the cloud. And so we need to support that. We need to support the ability to run containers from the file system, right? And not only that, we also need to be able to, we'll just say restart services for changes, right? Right now, we're not going to try and solve for the problem of a completely integrated development experience, right? The only requirement to verifying changes in this document is by restarting the service, right? So that's another thing to note. I'm purposely putting in this document and saying, hey, we're not going to try and solve the problem of, like this crazy, completely integrated experience where, you like save something and then like it just automatically kicks and rebuilds. If it's a service and it has a change, you have to restart the service. Like that's it, If it's if it's a front end, however, the file system should kick triggers in the container though, right? So technically, if you're doing front end builds, it shouldn't affect you at all, because if we're reading from the file system, Webpack, those other builders, they'll see that change and then they'll kick, inside the actual running container in Kubernetes. So that's a nice thing about that, is you will get a hot swap, and all that stuff still out of the box with Kubernetes. It doesn't really matter. It just matters that you're giving it, again, that appropriate file system and stuff. Exactly. Yeah. Let's see. Yeah. I mean, you can do it many ways. I've seen people like link in their like NodeMon, I think, is one of them. There's a bunch of like tools out there that'll like link to your save or hook into your save event and then like kick a service for you and stuff like that. I'm just not a fan of those. I save so often, and like I'll save to the beat of a song just because I'm vibing and like, I'm just like thinking. I'll just be like I don't know, like I do that for some reason, and like I don't want to be triggering like restarts every time I do that. So I don't really use those as much or really ever. I don't really recommend them personally, but that's totally up to you. If you want to use those, you can. I find them to be troublesome. If Kubernetes and Webpack can do that out of the box, it's all we need. Yeah, it totally can. 100%. Yeah, absolutely. Okay, cool. So we need to support the ability to run containers from the file system, right? And we need to be able to restart those services for changes. I guess another thing is need to be able to use need to be able to use absolute paths. So I don't know if this is a requirement, but actually I'm going to just keep that out for now because I don't know. I'm wondering how paths are going to work, because Kubernetes likes to make like absolutely sure where you're looking. So we'll have to take a look at that. But yeah, okay. So support the ability to run containers from the file system. Need to be able to restart services for changes. What else? So we've got the environment variables, right? We've got the ability of storing configuration and secrets and then providing those as environments to the container runtime. We've got all of the lower level orchestration for things like Knative, ingress controller, all of that. And then we have the volume mount for the ability to read the files and run them. So need to use generic language images instead of production build images, right? So the idea here is that we need to use generic images for development instead of production build images. So we're not going to be using the images that we build, right? We're not going to be doing this in a scenario where, and I guess to add more flavor to this a little bit, is we will use development tools inside of containers running in Kubernetes, right? And so the whole idea here is that this would be something like Webpack or TS Node, etc., right? And so what we're going to do is we're just going to run the basic like node, IE node, Alpine, whatever. And then that will have all of the tools inside of it. So that will also mean that we need to be able to access the node modules folder inside of the container. And the reason for that is because we need to use the development tools and things like that. So we'll put this here. That makes more sense there. And then yeah, we'll use generic images. Perfect. We need to be able to restart it. Cool. Yeah, exactly. Yeah, exactly. Oh, so yeah, we're not gonna use the so again, this would be like node Alpine, right? Or it could even be, Go Alpine, right? But whatever it is, these are the images that we're actually going to use. So we should have these packages installed. We're just going to use, Node for now, but yeah. And then need to be able to restart it. Okay, cool. So that makes sense. So yeah, so we now have our Node modules available to us. We have the image that we need, and we have the ability to restart that service. Any official ones, not self-made ones. I don't really think your development should be like super crazy to where you really need pre-built images for local development. In some cases, you just can't avoid it. And in that case, I totally get it. But for what I use, at least for Node, everything is in Node modules, right? So as long as it has Node modules and a valid Node version, I'm pretty much good to go, right? But if we're talking about like Rust, Go, things that require like, binaries or other library referencing ways, that might be a little bit more challenging. Okay, cool. So we're getting through this document pretty well. I think we're getting a pretty good understanding of like what we need here. We're not going to try and say, okay, cool. So run the containers from the file system. I think that's it, chat. I think that is mostly it. What do we need? So let's look at our deployment one more time. Everything else should really be the same, I think, just about, right? So our keys, all that stuff is good. The image will be the image that we've discussed here instead, right? So this image here will be just like, Node Alpine or whatever. We won't need image pull secrets because we're not going to be using something that we need to pull secrets with. We're not even going to be doing So this, interesting. We don't have a way of testing deployments. So let's do this. We're going to add a new thing here. We're going to say out of scope, right? And the first thing we're going to add that is out of scope is support for deployment or for init containers used with migrations. And so the whole kind of reason why I don't really want to deal with this right now is just because, and I'll write this, when we switch the image to a base image like Node Alpine, Node, come on now, get out of here. Node Alpine, we lose the entry point.sh. Everything okay? Okay, cool. We lose the entry point.sh that we normally use to. Okay, well actually hold on a second. We could reuse the entry point. So that is something we could do. But no, we wouldn't have. Sorry, I'm trying to think. So this container, when it starts, it has an entry point file that exists with it. And that entry point file, if we go to it, is very simple. It basically, if the command is migrate that's given to the container, then it runs a bunch of npm commands. If it's start, then it starts the application. Otherwise, It just says like, I don't know what this is, and fails. So technically, the script, the entry point script, will be in the container when we mount it via the volume, because it's with the what's it called, the repository. So that's good, right? Now npm does exist in the image, so we are actually okay with npm as well, right? We might be able to run migrations, actually. So I think instead of saying what's out of scope, what we need to say is we need to be able to support running containers using the entry point.sh, like in cloud environments, to match or for consistency. And so what we will need to do is add a like start dev or something similar to the script, and override the start command with Kubernetes, right? So yeah, what we could do is we could say, okay, let's go add something to our entry point.sh, right? And then in the command given to Kubernetes, the args, right here, we provide it. We'll have to provide it with the whole path to the entry point.sh, right? Because we're not going to have that as a actual command in the Docker file itself. So that's another thing to note is we'll need to be able to support absolute paths with running entry point.sh. So that might mean that, like, for example, the entry point.sh is something we possibly add entry point.sh, or we could just say possibly add script to path for global execution. Wow, I did not spell that right. Execution. So that's something else to note too. Whoa. What are you doing? Kubernetes. Okay, you can make an environment variable for it instead. What do you mean by that, Otzi? I like that. Okay. So at this point, we have the ability to node m, for example, if you want to run stuff in node. Oh yeah. No, I gotcha. Yeah. Okay, so this looks really good. So what have we talked about so far in this document? We've talked about the first thing, right, when we think about how the container starts, which is it needs environment variables, right? These are required, or the container will fail every time, right? Schmilly, what's up? How's it? Schmiley? Sorry, Schmiley, what's up? How's it going? I always say your name wrong the first time. So these are required, or the container will fail every time, right? We could say, then we need store configuration and secret value somewhere. We'll say, this isn't required. However, avoiding passing around .env files or equivalent is not desired, right? Is not desired. Then we want to be able to, again, support, multi-service local development in Kubernetes, right? And so the whole idea behind this is that when two services need to be worked on simultaneously, these can be deployed to the same local Kubernetes cluster. or to the same local cluster. They can then also be configured to point to each other in that local cluster and to the cloud for anything that's not in the local cluster, right? If we decide to support multiple services in development, which we probably will, then the cluster quirk automation will also need to be run locally for required services. So this will do things like deploy Knative, the ingress controller, all of that other stuff. Outside of that, what else do we need? So now, again, we've talked about the secrets. We've talked about storing the secrets, supporting multiple services, so like lower level dependencies. So then we need to be able to access the file system, right? We need to be able to access node modules so that we can get to the tooling. We need to be able to have an image that we can run these toolings with, right? We need to be able to then restart the container so that we can reflect changes. And we need to be able to support the entry point so that we can tell it how we want to start, as well as have different ways of starting the container depending on our choice of command. Do you use Reddit/NeoVim? No, not really. I haven't yet. No. Rainey, what's up though, man? Thank you for the follow. Appreciate you. No, I haven't. Why do you ask? Okay, cool. So this all looks good. So we have a service. Service is pretty straightforward out of the box. There's really nothing we need to worry about there. The other thing that's very, very interesting is the Cloudflare tunnel that we use. Oh, thank you. I appreciate that. If you're interested in any of my configuration, you can check out my dot files. Thanks, man. Yeah, I like pretty things. You know, I like to be able to use. You know, design is a nice thing for me. I don't know. By the way, that's an Ansible playbook, that dot files. It's a little misleading in the sense that it's not just a dot files. But if you go into roles in that repository and then click on NeoVim, you'll see everything that you need for the NeoVim side of stuff. Yeah. Yo, Diego, thank you for the follow. Appreciate you, everybody, by the way, for the follows today. So let's talk about this little guy right here, which is the Cloudflare record for the environment. Now, this Cloudflare record points to a tunnel, and this tunnel then allows us to route traffic from Cloudflare on any domain we want to any service that we want. In production, right, we use Cloudflare tunnels for all of our public services. So the API is running in Kubernetes privately, and then we have a tunnel deployed in Kubernetes as well that routes traffic from Cloudflare through that tunnel to our service. It's a nice little tool. It's a nice little feature that we can use. We need to think about how we want to manage that. Thank you. I appreciate your elegant choice in tastes. What's going on, Monty? How's it going? So this manages the record, which means the record will already exist for the tunnel, which means that the tunnel will be managed on the Kubernetes side in the cloud. So if we want to route public traffic to our local dev environment, everything up until now has been completely, I want to modify something locally. But with this one, it's different in the sense that this will route already existing traffic from our dev environment into our local environment. So it's the inverse. And we could do that. We can do that. So what this will say is that this is going to be in the multi-service local development, or actually this is its own thing entirely technically. What we need to do is we need to support routing existing dev traffic from the cloud to local environments. Now, again, this isn't something that's too terrible, but to give this a little bit more, again, information, if we are updating the API service and changing Twitch logic, then we need to expose the local environment to Twitch publicly for requests, right? So publicity, is that what I said? Publicly. Oh my gosh, I cannot spell. Publicly. There we go. Publicly. For requests. And so yeah, so the idea here is that we're gonna need to also I feel like that might be a challenge. It's really not. I mean, it just means that I go to the service deployment for Quirk and I run it in production. And update it. Again, this would be for dev, right? It wouldn't be for the actual production environment, but I could do it for the production environment if I wanted to, right? Like if I wanted to, I could route the production API service to a local dev machine if I really wanted to. I don't want to though, but yeah. So we could do that here. It just, again, it means what the downside to this is that we now have to manage something outside of like our current scope, right? What that is saying is that what might make more sense is it's got to be changeable. Otherwise, it's either we do it this way where we say, okay, it's configurable and dev can route to local services and it's only dev, right? If we wanted to, or we say we have separate environments for everything, and we're not really there yet. So what we'll put here is the only other solution would be to have fully featured dev environments for each branch. This is desired. However, third-party services like Twitch, Twitter, Discord all require static URLs for OAuth and other integrations, right? And so that's what makes it really hard for us to have these like dynamic service environments, because if we want to have, say, an OAuth app that we can, quickly check, does Discord OAuth work? I can't go into Discord and then be like, okay, let's create another app like that, unless I had a way of managing that with like Terraform or something, which would be awesome. Which we could totally make that, but it would just be, or Pulumi, I guess, it would be challenging. So that's a lot of the whole reasoning behind wanting to support dev traffic from the cloud to the local environments. We need to be able to support that as well. Okay, so this all looks pretty solid. We've solved the problem, again, very, very quickly about the environment variables, so the container won't fail at runtime. We've also solved the problem for storing, or we've talked about the problem, sorry, not solved it. We've talked about the problem of providing environment variables. We've talked about the problem of storing configuration. We've talked about the problem of multiple services and how we would support that. We've talked about the problem of supporting containers to run from the file system. We've talked about the problem of restarting services to reflect changes, and we've also talked about the problem of the entry point so that we can override how it starts, and then finally how services route to our local environment for reflecting changes, testing changes, all of that kind of stuff. I would say that is pretty much the full encompassment of a Quirk service. And again, if we look at it quickly, we're talking about configuration, we're talking about inter-service communication, we're talking about source files, or just how it's built. We're also talking about how it gets restarted, or how we reflect changes, how it's actually started as well. And if we wanted to give this a little bit more structure, we could just say like this can go under here. So we'll talk about how it starts first, and then how it's restarted, and then how we support routing traffic from an existing environment to our local environment. I don't really think there's much else that I can think of, or at least at the moment. I'm sure we'll run into stuff, but I think that this is a good enough, like, okay, we can move with this, right? Or at least we can kind of start solving these problems with this. Now, again, I already have a solution in mind, so, you know, we've already kind of talked a bit about it anyways, so it's kind of, you know, obvious, I think, in some regards on what we're going to use, but we'll definitely be talking about it. Would it be possible to make a little service that tunnels it to services listening to it, like a pre-server that read it? So yeah, no, that's not a stupid question at all. Let's see. There are fantastic tools out there. For example, like ngrok, right? If you guys don't know what ngrok is, this is a super cool tool, free as well, free by default, free HTTPS tunneling by default. By the way, chat, you can get HTTPS for free with these guys. But you know, a very logical solution to this could very much be, you know, just using ngrok, having an ngrok container that you maybe make yourself. I've done a little bit of research on ngrok. I have an ngrok service as well. Like, see here, boop, I have credentials. So, hey, don't try and break into my account, you mother. Just kidding. But no, I love ngrok. I don't use it as much these days just because I haven't really been needing it. However, one thing that, again, I do think would be super awesome, especially with this hybrid approach, right, that I've been showing you guys, is making it so that ngrok was the standardized, like, intermediate connection between everything, right? So, for example, in this, where we say need support for routing existing dev traffic, what we can say here is that if traffic exists outside of the environment, we'll say outside. If traffic exists outside of the cloud environment, then use tunnels as a way to expose local services to the internet, right? And that's exactly what we want to do. Is that if we'll say if the service, if the service exists outside of the cloud environment, then use tunnels as a way to expose it. Yeah. And so I think ngrok is a really good intermediate, like, you know, you could lean on ngrok very well for all of those, and, you know, they could just easily get dynamically generated. You then just go look at the ngrok logs for what your tunnel name was, and then take that tunnel and, you know, use it as your configuration. And again, that's something we could do. I don't have to worry about this right now. We could say not a concern at the moment as Quirk, development environments run on premises, which they do. They run on-prem at the moment. We only run in the cloud for production right now. So this isn't really a concern for us at the moment. Our dev Kubernetes cluster can actually connect to my local machine, but that is something to note about my environment that probably would not be the same for you guys. And we can even put this is probably not the case for most people as they deploy Kubernetes to the cloud by default, right? We have our Kubernetes, we have a Kubernetes cluster running in our on-premises data center. So because of that, I don't have to worry about that interconnectivity. It's in my garage. But again, this is probably not the case for most people, so I want to put that in there as well. Cool. Okay. So yeah, I think that's really good. So let's now talk about actually solving this problem, right? So we've talked a bit about what do we need. We can talk a bit now about what can we use? What can we use, right? So we could say by default, Pulumi satisfies all of these requirements as it manages the cloud deployments by default as mentioned above, right? This means that Pulumi can maintain our configurations in repositories and store secrets securely in the same location, right? That's one thing, right? What else does it mean? This means that Pulumi can maintain our Kubernetes automation, and even potentially share resource objects between projects for consistency, right? And so the whole idea here is like we store an API resource in a library, and then other Pulumi projects use that resource for deployments, right? And this would be, for example, the service API repository, and then, or the service quirk repository, and then, for example, the API repository itself, right? And so the whole idea here is that service quirk and API use the same resources. Now, what's also actually really cool that I think about this right now, and I'm going to do this over here really quickly. I don't know if we're going to be able to get to making this document today, but we should talk about Pulumi libraries, right? And we're going to talk about specifically resource libraries. And so the problem behind this one is we need a way to sharing we'll say custom defined resources, custom defined Pulumi resources between multiple Pulumi automation projects, right? Now, to go into this one really quickly, the goal really here, just to like TLDR, is we want to be able to import an API, we'll say a custom Pulumi API resource, right? Resource that can be then run in, we'll say, for example, that can be run in service quirk for production, or we'll say for cloud deployments, right? For cloud deployments, or service repositories like API with local development. Does that make sense? And so the whole idea is that if I have a resource that I can very much, just import as like a JavaScript import, right? Then I should be able to use that anywhere depending on just where it's imported. And so, the idea here would kind of be, we could say like possible solutions, right? The first one could be something like store all Pulumi resources in a, say like resource quirk repository that is maintained separately and downloaded from an upstream, right? And so the whole idea here is that this is actually really service directory at Hippo, but the main idea here is that we would have like a resource quirk repository that everything that quirk has is in, right? And this is all just Pulumi resources, right? And so what we could do is we could then say, okay, cool, We're going to manage all of our Pulumi resource configurations, like, basically, if we go to, let's do this. If we go to index here, right? You see how in my main here, I've got like API, WebSocket, Portal, Cloudflare D, all these. These are really like well isolated resources that I have created. They're really called component resources. You can see right here, component resource. But these component resources are completely isolated and movable, right? So what I could do is I could literally take these files themselves, put them in a library, right? And then make it so that these are a little bit even more configurable to where, I could say, I could give it the image as well if I wanted to say, okay, I'm going to run this image locally, but then this image here, or, whatever. This is, again, if you've ever watched the Hippo streams with Avi, this is very similar to what we use at Hippo called service directory, where it's this higher level abstraction that defines all the services and all the resources they need so that you can just import that module or whatever, and then, deploy everything you need like that with a simple configuration interface. Wait, no, I just realized that I just used Arch, by the way. So why not use Terraform instead of Pulumi? So I don't necessarily not like Terraform, for the record. Like, I want to be very clear on that. Let me bring my microphone down a little bit. Sorry about that. I do like Terraform. I've used it a lot. I use it at work. I use it like everywhere, honestly. And I do use Terraform with Quirk as well. As a matter of fact, if I open up, let's see here. If I go to Portal, oh wait, no, that's not where I want to go. dev.azure.com, right? Oh, don't tell me I have to sign in. I was like, you better sign me in. And we go to Quirk, for example, you'll see that in Quirk, we have a whole Terraform repository that has things like IAM user policies, service principals, storage accounts, storage containers, virtual machines, virtual networks, like, a lot of things. Kubernetes cluster, I think, is somewhere in here. Yeah, Kubernetes cluster. I lean on Terraform, or I have leaned on Terraform in the past for a lot of my more like cloud automation stuff. And what I mean by cloud automation, because it's kind of a vague term, is actual cloud resources. Things like buckets, or IAM policies, or things that are not the actual application deployment itself. And if you think about an application, you can kind of start to isolate, like, what's the application and what's the infrastructure, right? And so what I do, or what I normally have been taught to do as well, is to separate the infrastructure automation from the service automation. Like, keep those separate, let them run in parallel and change at any time that they need and not really affect each other, right? And so this automation, this low-level this is like the cloud level automation, right? And so Pulumi really right now sits on top of the Terraform automation, where we create all of the low-level cloud resources, right? And then we run Pulumi against the Kubernetes cluster or any other clusters that are created and stuff like that. I could run everything in Pulumi if I wanted to, but I will say that Terraform is a lot easier to set up. So one of the things that's nice about having all of my cloud automation in Terraform, or all of my very verbose stuff in Terraform, which would be, creating RDS instances, or, really anything cloud related configuration wise is kind of a nightmare. But yeah, using HCL and Terraform for that is a lot easier, because you can get very minimal, setups in Terraform. Whereas like Pulumi, I use it with Kubernetes because of how advanced Kubernetes requires the way of managing it. Terraform is nice with it, but it just doesn't compare to to Pulumi. I have to go to sleep, got to work tomorrow, have a straight stream, I'll watch the VOD tomorrow. Yeah, Otzi, by the way, hey, I just want to shout this out to really quickly to everybody. I haven't put the YouTube video or the YouTube channel out there yet, but let me go ahead and do it right now. We have a new YouTube channel, which is funny because like we're still trying to launch our other one. But we have a YouTube channel called the Alta 4 Archives. And that's where all of our VODs are going to be. So we are going to be starting with the last VOD, We are going to be uploading all of our VODs to YouTube. We have to wait 24 hours before we can do that. But just know that they'll always be available on Twitch. But then 60 days after Twitch deletes our VODs, womp. And so they'll be on YouTube for you guys too. So, yeah. Yeah, so don't worry about that. Yeah, they'll be there. Let's see. Yeah, and if you want, when I upload it, I will DM you. I'll shoot you a DM so that you know that it's uploaded. Yeah. I'm curious, do you purely run Linux or do a dual boot? So Monsi, if you're curious on my dev setup, the TLDR on it is that I wanted my cake and I wanted to be able to eat it too. I am somebody who streams on Twitch, who wants a very high quality stream, something that's nice. I want to be able to play video games. I want to play the latest video games that I can. I want to be able to, do all of these. I want to be able to develop as well. And so my solution to that was actually running a virtual machine. Now that might sound crazy, but I have a very, very powerful computer. And it's actually very easy for me to run VMs. As a matter of fact, I'm running 2 VMs right now, Arch Linux and I'm running 2 Arch Linux machines, but an old dev VM and my new dev VM. But TLDR on that is I went this VM route because it allows me to, again, do everything, do all of my development, work on everything I need to, have the access to everything I need in a pure native Linux environment, and then just shut down the VM and go play video games or do other things like that. And do I get good performance? Yes, I get. Let me put it this way. I get performance to the point where I don't notice performance things. So yeah. I guess that's my easiest answer to that, is I don't really actually notice it. But again, I have a very powerful computer. I have an i9 9900K. I have a GeForce 2080 Ti. It's not the slowest of machines. But you can get that kind of performance, I think, out of a lot of stuff. I don't think it's just my machine that could do it. I think a lot of machines could do that as well. Okay, so we need a way of sharing custom defined Pulumi resources. So this is something that we could do. So we could store all the resources in the resource quirk repository, or we could store each Pulumi service in its own repository with the service and use that as the import. And so the whole idea here would be that I guess it would still have to, this is, so I guess we could just say downside here is we would require to publish a lot of node modules to make this work. So for example, it'd be like an API, a WebSocket, all of these would be their own node module that would get importable versus this, which is downside. We are required to manage all service configurations, and I don't really know if this is a downside but we say we are required. We'll say not downside, but we're required to manage all service configurations and secrets in one location and publish. This will be the challenging part. Publish the module for changes, right? So that is kind of the downside here is that this not so much. This is actually kind of nice having it all in one space and being able to easily maintain it. But this is the tough part, publishing the module for changes, how we can get around that. So we'll see. Whereas again, if we store each in its own, or we'll say in its service repository, each Pulumi resource in its own service repository with the with logic, and use that as the package. Not really the package, but the import. And so yeah, the downside to this is even though we now have the isolation of saying like, okay, the API service exists right here in this one package, and I can easily pull the API package and use that service. We have a bunch of microservices. So saying like, okay, I want to pull down again, we're using node for this. So the equivalent would be doing like npm install -- save, quirk, right? And then, oh, that's not what I want to do. We'll say, oh, come on now. It'd be doing something like this. Sorry. Oh, that's right. This isn't, okay. I need to turn this into a code block. There we go. It'd be doing something like this. npm install -- save, at quirk, and then, you know, maybe like, Pulumi API, right? Is save the default now? I didn't know if that was the default or not, but what it is not the default, which is what we would want probably, is save exact. But that would be the thing, right? Is we would have to do something like this, and then we'd have one for, you know, WebSocket, right? We'd have one for, portal, right? So that is a bit of a difficult thing to manage over a period of time, is, you know, all of these different packages that'll have to be updated every time we do a resource change, making sure that all the downstreams get updated as well. I don't really think we want to approach this versus something like this, where we just say like, okay, instead we just use one package, and this will be like quirk, Pulumi resources, right? And then this would make sure that it had everything with it. What's up, Viable? How's it going? Is a 10th gen i7 with 32 gigs? Yeah, I think so, Monsi. Yeah, my best opinion would be just to try it, you know. I really think you can, you know, you can test run it with, you don't have to, like, I use VMware Workstation. I think it's, you know, my favorite hypervisor. And if you want something that really will give you performance, then use VMware Workstation. Yeah, I mean, you could get other hypervisors out there and at least kind of test it, or test performance it, and see how it goes. But I would say that's probably fine. Yeah. I run an i7 on one of my MacBooks, and that runs pretty well. I highly recommend nx.dev. What is that? I don't know what this is. What is this? Smart. Are you saying like build my own build system? Is that what you're saying? For like create an NX workspace? No idea what that is. Interesting. Oh, interesting. Manages the monorepo of many node packages. Oh, it's okay. I see. Is Pulumi better than Terraform? I don't think one is necessarily better than the other. To be honest, I am not a fan of HCL, right? That's one thing that's challenging, is like Terraform is not HCL. It is not. Terraform, instead, Terraform uses HCL, right? It is not HCL. So, for example, if you wanted to, you could use Terraform with JavaScript or TypeScript using CDK instead of using HCL. The problem is most of the things out there are supported with HCL. Or it's just like documentation's better around HCL, but there is something out there called Terraform CDK. And CDK is essentially Terraform that allows you to find resources in things like JavaScript, TypeScript, Python, Java, C#, and Go. And then that will compile down to HCL or something like that, so that you can do that. So, you know, do I hate Terraform? No. As a matter of fact, Orca, who's one of our mods in our community, he has been running tests and deploying stuff for what we call our janitor cluster at Hippo. And this janitor cluster is designed to handle janitorial tasks, basically cleaning up repos or cleaning up other things, you know, cron jobs, backups, restores, things like that, whatever. And that's all automated with Terraform CDK. We chose not to use Pulumi when we wanted to, because we still use Terraform for things like, you know, Terraform Cloud. It really is desirable to have Terraform still. So we decided to use Terraform CDK instead. Again, it's not Terraform that's the problem. It's HCL. So yeah, no, I don't hate HCL. I just am not the biggest fan of it. If it's simple and easy to automate, then HCL is honestly great. And that's exactly what I use it for. Very simple, easy automation. But once it gets to a point where it's like, okay, I need to do a bunch of other stuff, then it becomes a little bit more challenging. All right, so let's go back to our main document here. Yep, that's true. Yep, you could use Hyper-V. Hello, BG. Sorry to distract, but I am looking at Pulumi as more modular automation tool versus Terraform, but my background is not programming heavy, so I'm hitting a wall when trying to grab the output so I can push an Ansible playbook to an IP address the VM gets. Whoa, hold on. Wait, what now? So you're not distracting. You're fine. This is why we all do, DevOps and stuff like that for a living. I'm trying to understand your question. I'm looking at Pulumi as a more modular automation tool. I want to say this very quickly about what you're saying. Technically, if I sat down with somebody at HashiCorp and I said Terraform was not as modular as Pulumi, they would say you don't know how to program. It's very modular. It's entirely as modular as Pulumi. It has the same possibility of having in and out interfaces, kind of like what you're saying. It has the ability of importing it very different ways. You can import modules via, SSH. You can import them via HTTPS. You can import them relatively. It's just different in the sense entirely of how it's declared and how it's designed. What becomes difficult is really it's just an HCL, right? Than like a normal programming language. So that's why I think a lot of people are like, it seems more logical to have modular components in a language like TypeScript or Go than having module components in HCL. But as a matter of fact, Terraform promotes you using very modular components where you create module, I think they're repos or something like that. And then you import those repos with very specific defined interfaces and use those. And those are like custom, repositories essentially. And that can get as granular as you want. At Hippo, before I worked there, when I got hired in, we had RDS, we had custom RDS modules so that we would import an RDS module and then configure it. We don't have that anymore because we changed entirely how our DSL works, but still that's super granular, and you can have the same granularity with what's it called as well? Pulumi. So yeah. And again, you're not distracting or anything like that. I just want to make sure that is clear. But my background is not programming heavy, so I'm hitting a wall when it comes to grab the output so I can push to the Ansible playbook. So here's my other question. So you're saying that you're trying to grab the output so that you can push it to an Ansible playbook to an IP address the VM gets. This is where I get a little confused. So can you help me understand what you mean by grab the output? Where are you grabbing the output from, or where are you expecting that output to come from? And then what are you trying to use that output with an Ansible playbook, or can you help me understand where Ansible comes into play there? Sorry, just so that I have a better understanding. I want to help. I definitely do. I'm just a little confused. Does Pulumi support things like Terra, Dry, etc.? I think so. Yeah, I believe so. I could be wrong. I mean, I don't really exactly. Wait, what is Dry again? Give me. What does that acronym mean? So I can remember. Terraform has also released a bunch of updates during the recent 6 months. Don't repeat yourself. Oh, yes, it does. Yeah. Sorry, yes. It's stateful, Ricky-tastic. So it maintains all the state like Terraform in a state file, and yeah. Terraform has also released a bunch of updates. Oh, yeah, yes, it has. Yeah. The amount of unreadable HCL logic I've written is almost as criminal. Yeah, I mean, it's very common. It's very common to start out with very simple logic and then 2 months later look back and just be like, whoa, what just happened? You pull a Hank Hill and you just go, whoa. By default, Pulumi satisfies all of these requirements as it manages the cloud deployments as mentioned above. I did not realize I repeated myself there. This means that Pulumi can maintain our configuration in repositories and store secrets securely in the same location. This means that Pulumi can maintain our Kubernetes automation and even potentially share resource objects between projects for consistency. We'll say created / link to page, and then I want to link to notes, not notes. Why did you go to notes? I want you to go to Pulumi resource libraries. So go back here, go all the way down here. Oh my gosh, stop it. Delete. Created Pulumi resource libraries, technical document for further investigation. We stored API resources or API resource in a library, and then other Pulumi projects use that resource as deployments. Yeah, that's good. That's good. What else do we need? So we've talked about that Pulumi can handle the configuration stuff. This means that Pulumi can maintain our Kubernetes deployments for environment variable injection. And then we'll say this means that Pulumi can even potentially share resource objects between projects for consistency. This is, well, I'm not going to say this is out of scope because this might be something we actually need to look into. Okay. Okay, so what else? What else was in this list? So we talked about the environment variables, got the configuration, multi-service local deployments. Yes. This means that Pulumi can manage multiple or multi-service deployments to the same Kubernetes cluster, while also providing the same interface for managing cloud clusters. Right, so that's nice. We can get rid of this means that Pulumi can manage. Okay, can manage. So let's talk about this a little bit more as well, though. So right now, we have services that are in one project. And so currently, we have all existing services or service resources in one service quirk repository for deployments. Right? So that's how it works right now, is that all of these only exist in that. To make this work, we will need to recreate the service resources only for that given resource in the source code repository. And so the whole idea here is that this automation or this repository here, service quirk, is really only focused on creating all of the environment and deploying the services to Kubernetes for it. That's it, right? But we can't reuse that when we're developing only one service, right? What we really kind of want is we want to recreate only that service, and then as we add more services, those services kind of, like communicate with each other as they appear, whether it's in the cloud or locally, right? So for example, in the service quirk repository where we have everything, in the API repository, we'll have just that one API module. And so we can say to make this a better development experience, it would be good to investigate how to use Pulumi resource libraries, right, as mentioned above. So this is really why we're sitting here thinking about all of this, because this is an exact case where you guys would have tripped up just as much as I probably would have, where you'll get to somewhere where you'll be like, okay, yeah, I'm implementing this. Okay, cool. Yeah, this all works. And then you'll go, oh, this isn't going to work for what I need. Or, oh, this is like not a good convention. This is going to be something that's going to be trouble lately, right? This is why we think about these things and write out these documents so that we can predict these things and kind of be prepared for them. I mean, look at how much we've already gone through and talked about just by discussing what our requirements are, what do we need, you know, how, if we use something, how well will it work, right? Before ever writing a bit of line of code and wasting any time. We're not really wasting any time right now because we're really just working through the problem. When the VM comes up, it grabs the DHCP IP address. I export that and a few other VM variables. I was hoping to use Pulumi command local command to run with Ansible playbook against it. Oh, interesting. Yeah, I don't know if interesting. I would check your PM. Is that, are you trying to help? Check your PM? Oh, no. Okay, my bad. I thought, okay, that's a different thing. When the VM comes up, it grabs a DHCP address. I export that and a few other VM variables. So that VM is being exported via Pulumi, correct? I just want to be clear on that one. That's my first question. Are the VM values being exported via Pulumi? And then you were saying that you were hoping to use pulumi.command.local command to run an Ansible playbook against it. So then what you're saying is you want Pulumi to run your Ansible playbook. Is that correct? So again, two questions. First question, is Pulumi what is exporting your DHCP addresses and provisioning all of your VMs? And then two is, are you wanting Pulumi to run Ansible for you? Pulumi can manage self-manage. Yep. Okay, cool. So this looks good. Okay, so let's talk about Pulumi giving access to the file system. That one is pretty straightforward. We could say Pulumi can manage Kubernetes volume mounts for access to the file system, and using Node can predict relative paths for mounts. Right. And so this was something that we were kind of worried about. We're like, is it going to work for local paths and stuff like that? It totally will. If we use Pulumi, we can use Pulumi to check a path, or check for the local path or the current path, and then access the absolute paths via that. So that's another check mark for Pulumi. Because we are using JavaScript, we can lean on JavaScript logic and use automation with that logic to really make, super nice deployments. Okay, cool. So that's good. We can run containers from the file system. We need to be able to do generic images. Pulumi can do that. We need to be able to override the command. We can do that. So need to be able to restart services for changes. So here's where it gets kind of interesting. Pulumi is not able to restart services unless a change is given to the state of the cluster, right? So if that's the case, then if we want to restart a container in local development, we can just use the kube control command line to restart the deployment, right? Now, we can also say, ideally, this would only be one container to avoid extra wait time during restarts. One other thing to note about this is also this will also verify that health checks health checks and other deployment mechanisms are working properly. So that's kind of nice too, is if we, kick the service or anything like that, that it should make sure that when the service restarts, the health checks restart as well. And everything's working. Yes, via Pulumi export. Yes, I want to run Ansible for me because I'm lazy. So here's what I'm just going to say to you. Anytime anybody's done anything lazily, it's never really worked out great, has it? I hate to put it that way, but it's kind of true. So, that's going to be my first kind of advice to you, I guess, is like, just remember that you know a bit of what you're getting yourself into when we talk about running Pulumi with Ansible. There are obviously better solutions for that. I would almost beg the question, could you do some of what you're trying to do with Pulumi? Is that possible? And if not, is this something that actually makes more sense for you to run in Ansible? And if you need the two to run together, then just make it so that one runs after the other. That would be my honest opinion, right? And figure out a way of passing the values between those two runs. So if you really wanted to get, super, neat with it, I guess, you could have pipelines, right? And these pipelines do specific things. They don't necessarily have to be pipelines that run with your code, but they can be pipelines that we call continuous delivery pipelines. Ooh, I said continuous delivery, not continuous integration. Isn't that crazy? I didn't say CI, I said CD. And that's because that's what CD does. It delivers things for you. And so what you could do if you wanted is you could have a pipeline that first runs your Pulumi delivery automation, right? The actual automation that delivers your application. And then after that, you could have a pipeline get triggered from your Pulumi automation with the parameters that you export from that Pulumi automation, right? So with a little bit of trickery, say in your CI/CD pipeline or in your CD pipeline, after you run Pulumi, right? You say get those exported values somehow via the CLI, and then you trigger another pipeline with those values. Now you've just triggered an Ansible pipeline with the values from your CI/CD, whoever, Circle CI, whatever. But at that point, it's a lot easier, right? Now you just have two interfaces. You have one interface for running deployments, right? And maybe parameters you give that. And then you have another interface for running, Ansible and maybe parameters that you give that. And both of those are pipelines that exist, again, in your continuous delivery system. So that would be something I would recommend more than just trying to hack the two together like that. And yeah, what would be your use case for Ansible? In the approach that I described, it doesn't really matter what the use case is. But yeah. Okay, cool. So Pulumi is not able to restart services unless a change is given to the state of the cluster. If we want to restart a container in local development, we can just use, yep, that's fine. Cool. Okay, so we have talked about file system, restarts, and then traffic. Okay, so here's the last part, which is the Pulumi can update cloud deployments to point to local deployments for development testing purposes. And so the idea here is that updates will need to be made to the following repositories, or updates will need to be made in order for this to work. So the first one is going to be we need to update / deploy the local Kubernetes environment. That's going to be the first thing, right? And then we need to retrieve the address or URL for the local development services. Right now, this should be a public address that external exe external cloud services can access, right? And then after we retrieve that, we need to update and deploy the cloud Kubernetes environment, right? We'll say update and /or deploy, and we'll say update and /or deploy. So it's 3 steps. We first get our local environment set up so that we know that it's running, right? We then get the value of whatever's running, in this environment, right? And then we finally update our cloud environment to point to our dev environment for the services that we need. That looks good. And if we look at this chat, this really does satisfy a lot of what we needed, right? And again, now that we go into this, or now going into this, we can really confidently say that I think we know what we are going to expect, right? In the sense of how we're going to manage Pulumi, as well as, how other services are going to work with our local stack, how our local stack is going to work with other services, the dependencies that is required to running those local services, and all of that. So here's what I want to do now. What time is it? It is 5:47. Okay, cool. So here's what I want to do now. I would like to quickly take a break because I've been going for 2 hours now, and I think we have a pretty killer document here. But before I do that, I'm going to go ahead and upload this document to the wiki so that you guys can see it as well. And so we're going to say that this is the local development with Kubernetes. And then I'm going to grab all of this so that you guys can at least look at the document and all that good stuff, So here, we'll paste that in. And then we will go here, insert table of contents. Problem, we have no consistent way of doing or of deploying local development environments for microservices in a sane and manageable way. Below outlines we have for each cloud environment, or each environment, each environment. What do we need? What can we use? Okay, cool. All right, so as I said, chat, whenever we create documentation, we also upload it to the wiki so that you guys have access to it. So I'm going to go ahead and do that right now. Yo, Superman, thank you so much for the Prime. Hold on, give me 1 second. Honestly, I've seen 3 general use cases: Ansible's mixed conf management, like it's all this, configure that. Yep. 2, purely installation of packages. Yep. 3, managing cloud resources which can be shipped. Yeah. It would be for twofold: deploy, redeploy a company application within a test environment for multiple networks, and deploy infrastructure. Also working with libvirt, so that's fun. Oh geez, good luck. Yeah, libvirt's fun, but it's open source, so that can also be challenging. Thank you both. I have some testing to do. Yeah, of course. Thank you, man. Thank you for your Prime sub too. Thank you. So check it out, chat. This is for you guys. This document is the document that we have been working on stream. That is right, chat. We just made a document on stream that you guys can now at least take a look at, access, and start wrapping your heads around. And again, this whole document is focused on local development with Kubernetes, and I'll say local development for Quirk. Yeah, we'll put for Quirk as well. So here, this is going to change this URL slightly. Once I save it, there we go, for Quirk. There you go. That's the new URL. Check it out. That's the new URL right there. Again, I just broke the old one, so check out that new URL. But yeah, this will at least give you guys some of a good understanding of what we're trying to do, why we're trying to use it, and all that good stuff. So when we get back, or when I come back, we're actually going to start writing some of this automation. We're going to start trying to figure out how some of this can work. I think what'll end up happening is we will start investigating this Pulumi resource libraries. Actually, broken URL works as well. Does it really? Oh, nice. It must set up like redirects or something like that. Yeah, it must set up redirects or something like that. Awesome. So I think this is something we're going to need to take a look at. I don't know how far we're going to get with it, but I do have a slight suspicion that we're going to need to create a module of sorts that we can import and use with our automation, rather than having those resources just exist in different automation projects. And again, the whole point of this is that if I have an API automation that exists somewhere in, again, like a production deployment, I want to be able to take that automation logic and then put it in a local deployment and it be identical, right? And that's really where Pulumi resource libraries can be powerful, where I can create a node module that has, all of my Pulumi resources inside of it and then export that with custom definitions. So I think we'll take a look at that potentially first even, because I think that's going to be kind of a requirement for what we want to do. So we'll see though. Yo, Jacob, thank you so much for the Prime sub, man. Appreciate you. Thank you, dude. And for almost triggering the hype train. Appreciate that too, man. Thank you guys again for hanging out with me today. Again, this was totally impromptu. This was something I needed to work on because I knew this was something I needed to solve. And I want to exemplify this too. One of the reasons why I'm trying to solve it this way with so much focus and just like consideration is that I want to make it so that Quirk is easy to work on. It's scalable. It's something fun to work on. And I don't have a really good process to even work on Quirk right now. And if I wanted to try and develop Quirk, it would be very challenging. So even though, and I think this is also part of me getting hopefully better at what I do, is identifying the right problem, right? My real problem is not that I need to get, this service updated or this fixed or whatever. It's more, I need to get my development process working better so that I can enjoy developing better, so that I can get things built quicker, right? And so that's a much better solution for me, because if I have a more improved development environment locally, I can develop faster. It's easier for me to make changes. And then that whole process just makes it easier for me to get stuff out the door. So that's really what kind of inspired this whole stream today. I was thinking about streaming. I didn't know what I wanted to stream. But then I sat down and I was like, I think the real problem as to why I don't feel comfortable streaming, Quirk even on Twitch right now is because Quirk is in such a broken state. I'm constantly dealing with like environment variables and secrets and stuff like that. But the cool thing about Pulumi as well, and this is something, that I can literally do with you guys, is like all of these, all of these values are encrypted. I can go to the production Pulumi secrets values and look at, you see how all of these are prefixed with secure? That's because all of these are encrypted. These are all encrypted values that Pulumi has allowed me to now store in my repository. So, again, leaning on Pulumi is really powerful for stuff like this, and it'll help me solve those problems of like, managing secrets or what are really annoying about dev work. So yeah. All right, I'm gonna take a quick break. I appreciate you guys being here. If you are new to the channel, ooh, I don't know what that was. Be sure to check out that little blurb right there, as well as our wonderful Discord if you ever want to be a part of the conversation, social media, all that good stuff too. Again, the stream's not over. I'm going to take a quick break, and then when I come back, we are going to start working on this with, again, I think the Pulumi resource libraries. I think that's where we'll actually start. So give me a minute. I'm going to run an ad as well. If you don't know why we run, oh my gosh, I did it again. If you don't know why we run ads during breaks, that basically explains why. And I will see you in a few moments. All right. All right. Give me 1 second, guys. Be right back. Oh, shit. Hey, what up? Hey, guys. Yeah, we will be right back. Yo, Griffin. Thank you for the raid, dude. Welcome, everybody. Sorry for my tardiness. I was taking a break. I have no idea how long. Oh, it happened a minute ago. Okay, perfect. That's like perfect timing. What's up, though, Griffin? How's it going, buddy? Shout out to CM Griffin, the wonderful, fantastic CM Griffin. How are you, buddy? I delayed it as long as I could. I appreciate it, man. Sorry again. Sorry, I just taken my break. Welcome though, everybody. How are you? I hope you had fun over at CM Griffin's stream. I'm gonna be real with you, Griffin. We were talking about it earlier today. I'm getting hyped for TwitchCon, my dude. I'm excited. Actually, you know, also what's funny, chat. Here's a funny little tidbit about CM Griffin and the Alt at 4 stream. We've hung out together in real life. We've hung out together in real life, yeah. Fun fact, we hung out at the last TwitchCon together, so hopefully we will be doing the same at the next one. Jenga, yeah, the Jenga, yeah, we hung out with a bunch of people, actually, 2 years ago. I hung out with Prime and Jordan and Talk to Me Gooseman and CM Griffin and Raimu and yeah, bunch of really cool people. The OGs. What's up, Owen? How's it going, man? Code Dissect. Hello. Sock hello. Perp Sherp. What up? Thank you guys so much for hanging out. I appreciate it. Let me give you the spiel, the old rundown, the old 1-2. My name is BG. I am one of the co-hosts of the Alt at 4 stream. If you are new here, there's a little bit of a blurb there for you to give you a little bit more information. I program basically my co-host Atoda, who sits right behind me. As a matter of fact, if you'd like. That's his desk back there. That's his desk back there. Sorry. So yeah, this is the Alt at 4 stream. Again, as a co-hosted stream, I program, he games. We also co-host streams together sometimes where we play video games, do a bunch of other cool stuff. So thank you for being here. I am currently working on something called Quirk, and I'm in the process of setting up local development environments for Quirk. Now, what that essentially means is that whenever I want to update a service, make a change, patch, fix, whatever, I need a way of being able to do that locally, consistently, and easily, right? I need to be able to, run the service, test it, deploy it, all that good stuff, and not be concerned at all about it. We deploy to Kubernetes by default, and we use something called Pulumi to do so. And so before this, I was using Docker Compose, as I'm sure probably a lot of you use as well for local development. But the problem I ran into was the type of requirements that I had with regards to how I deploy my service, all that kind of stuff. Hang on one second. Sorry about that. Had to get up for a second. So anyways, local development. Like I said, where was I? Oh yeah, Kubernetes. So anyways, we use Pulumi and Kubernetes in the cloud. But when I tried to use Docker Compose, some of the things that we do with Kubernetes and Pulumi and the automation didn't really translate really well to Docker Compose. As a matter of fact, some of those were related around like certificates and how we injected those certificates. Did we want to change the application code? Did we like how it was managed? Things like that. And so the overall opinion was Docker Compose, though it is great and has taken us far, far places, isn't really something that I think is going to solve it for us. It's not really something that, is going to really help us in the sense of developing. And so I was like, all right, well, if I'm not going to use Docker Compose for local development and starting containers, like what am I going to use? And so I started toying with the idea of actually using Pulumi. And so before you guys got here, not this one, but I created a whole article, and this is something we're doing now pretty much all the time on the stream, which is I work in DevOps, and part of my job is documentation. Part of my job is sitting down and saying like, okay, what is the process, or what is the problem? How do we fix the problem? How does it work? Like, where do we see the problem? Asking all of the questions and then putting it down on paper. That's just part of my job. And I want to get better at it. I want to get better at it every single time I can. And so we also deal with a lot of different types of problems here on the Alt-Dev4 stream. Sometimes I'll be doing DevOps, sometimes I'll be coding, sometimes I'll be testing things. It's a very ranging experience with the kind of stuff we do here. And so I wanted to figure out a way of saying like, okay, there's stuff I want to put on YouTube, there's stuff I want to put on Twitch, there's stuff I want to, put elsewhere. So where was that elsewhere? And so we created this thing called the Alt-Dev4 Wiki. I think it's just Wiki. Yeah, Wiki. And this wiki is really kind of like, if you've ever heard of like the Arch Wiki, it's the wiki of us and everything that we do. And anytime I create like a new or topic, or we talk about something, or we work on something, I want to be able to create a technical document that you guys can reference and be able to take with you right away. And so we created a technical document on local development with Kubernetes. Now, this is in reference to Quirk, the application that I'm building. So when I posted it on our website, you'll see that there's a local development for Quirk, or local development with Kubernetes for Quirk article here. And this article is what we just created. So if you guys are curious about essentially what we just did, you're welcome to check out that article there. Okay, awesome. So TLDR, we are trying to do local development with Kubernetes. Now, we, in this article, also created and said that we would like to try and use Pulumi to automate that deployment. So again, when I say like, I got rid of Docker Compose, something has to start the containers. Something has to make sure they're deployed, or, whatever. And that something is, in this case, going to be Pulumi. And so the idea here that I'm rolling with is that in the same way that Pulumi helps us deploy our services in production to cloud environments, we're going to use it to run our local environments. And so just like using Docker Compose up, we'll use like a Pulumi up or a Pulumi update, and that will go to our local Kubernetes cluster and deploy our local development application to that cluster. Now, is it going to deploy everything? Yes and no. It's going to deploy everything that every service needs, in the sense of like, if you've used Kubernetes before, things like ingress controllers or load balancers, right? Like support for things like that. Those are low level cluster resources that like every service needs. So that will be in every deployment, yes. However, that automation is actually very easy to solve for. Already has the ability of being deployed locally, and is no problem whatsoever. And I'll show you that in a minute here. But for the second part, which is the services stuff, instead of using our main automation repository for how we deploy all of our services, we're going to have automation in each one of our service repos, right? API, WebSocket, whatever. And then we'll have automation that will run inside of that we can then deploy locally with Pulumi. And so that will just deploy the API service, point it to the cloud, and then we can, once that service is deployed, point the cloud back to us locally and start developing. And I know it sounds a little bit complicated. It's really not, but don't worry, we'll get there step by step. I don't know if we're going to get through everything today, because I don't want to be going super, super late, but we'll at least get through what we need to. So, D-Rod, thank you for the 28 months with the continued Prime sub, my man. Thank you, bud. How are you, dude? Have you had issues with your devs running Kubernetes on Apple Silicon? We don't have anything on Apple Silicon where I work. We don't run on Apple Silicon. So two things. One, where I work, IT is actually in charge of all of the like laptops and all that stuff, right? That's not something we really control. And two, it's heavily tested. If there was a certain thing in particular where we felt like it would affect more than two people, which just a lot of things right now, Apple, M1 chips do, we just wouldn't support it for that reason. So it's more just, standardization and making sure that we're not like shooting ourselves in the foot trying to use it. Yeah, exactly. I mean, it's like one of those, oh, it's really shiny and you want to play with it, but then like you get burnt once you do. And we just like at Hippo where I work, we don't do that kind of thing. So, yeah, it would have to get approved through many different departments for it to work. Okay, so when we talk about this document and what we wrote and essentially how Pulumi can help us, we can kind of start talking about like, when we talk about like, well, what can we use? We can start talking about like, okay, well, what are the things in Pulumi that we need, right? So we need a way to manage deployments, right? So we're going to need some type of repository. Now, we already have a repository for each service in the sense of if I go to dev.azure.com, which is currently where a lot of the source code exists, we should see that I have, hold on. There we go. We should see that I have some service repositories like API, Mailer, Terraform, Webhook, Twitch event. Now this Mailer one, this is old, this can be deleted, but the API is active. That's the API service we use, for everything. So this repository is where we can put our Pulumi automation if we want to. And so the idea here is that just like we said in our document, we want to be able to do Pulumi up in our service repository. Yep. Service repository, sure. But we want to be able to do Pulumi up or update in our service repository or this repository, and then be able to run the automation of just this one service's deployment, right? And it'll deploy it locally to the cluster that we have running locally. I'm glad that you like potatoes. Robotic, thank you for the 7-month 3 subs. Thank you, buddy. Thank you. How you doing, Robotic? Shout out to Robotic Head, by the way. We do use M1 at work, and I can confirm there's a lot of unresolved issues even with Docker itself. Yeah. I'm sorry to hear you have to deal with that. That kind of stuff is really annoying. Okay, cool. So let's do that then. Let's go ahead and create a Pulumi repository. So we're going to say pulumi.com. Now I already have kind of a structure here set up. We don't really need to go with this before. What am I orchestrating? I'm just do exclamation mark today in chat. Pulumi documentation. Oh, also here. Let me go ahead and update the today with the latest thing. See this TDD or Pulumi for more. And then here. Did you? There you go. Okay, cool. So again, this is counter to how we do automation in production, right? In production, we have this service quirk repository where, again, if I click on a resource, you could see API, bot, like all of the actual services deployed to the cloud. So what we're really kind of doing is we're going into this, looking at each deployment, and ideally, and this is where the other technical document work we were working on comes into play of the Pulumi resource libraries, where we say, okay, well, Service Quirk needs this resource, and so does the API itself, right? Now, this should just be the deployment specification. It shouldn't be anything else but that. So let's have a repository that has those deployment specifications. We'll call it maybe like a service directory. And then, import that and use that as the deployment for our actual Pulumi automation. And so we can do that. And again, that's kind of why I said, I think we're going to need to look at Pulumi resource libraries first before we actually start getting too deep into creating the automation here. But we can at least get started with the automation in the sense of wiring up a basic repository. Now, Pulumi does have some automation or some documentation out there for getting started and stuff. We can go to Kubernetes here. Before you begin, whatever, we've already got this installed. Just tells you to install the CLI, install your runtime node in this case. No, you're good, commentator, you're fine. And then it says make dir, create your directory, and then do Pulumi new Kubernetes TypeScript. And so at this point, you go through the process of creating your project. And again, we can do this Pulumi new Kubernetes TypeScript. Rerun an empty directory or use force. Oh, I see. Okay. That's fine. Let's create a new directory and we'll call it Pulumi. The reason why we're doing this is because Pulumi is in JavaScript, or at least you can use it in JavaScript. And by default, that's what we're using. We're using TypeScript, right? It's going to manage its own package.json and all of that fun stuff. And so ideally, we don't want that to conflict with like our package.json or, you know, any other that we might have to add later on. So I'm going to create a Pulumi directory that is completely empty, and then we'll do that in here. And so now it shouldn't complain. And so the project name will be Quirk API. And so this will be the project in Pulumi. Now we use Pulumi Cloud, so I want to kind of note that as well. Pulumi Cloud is, hold on. Pulumi Cloud is basically their cloud product where it allows you to store state for your applications in their service, and then also like see pipelines as they're running and stuff. Now, it doesn't actually have runners. That's one thing I want to note here is it doesn't actually have runners itself, but it does allow you to see the output of Pulumi ran code. And you can see here we've got a bunch of already projects set up here. So cluster on-prem, right? This is all of our on-prem Kubernetes automation. The Quirk automation as well. And you can see right now it's just test one environment, which is actually nothing. You can see service Quirk as well. This is where we've got dev, prod, and test. Dev and prod are the only ones deployed. You can't see it here, but there's actually no resources in test. Test is completely empty. But what you might notice is that cluster Quirk, right? We said before that cluster Quirk is the automation for all Quirk environments, right? But then here we've only got test. So how is the dev and the prod environment deployed if we've only got test here? And the answer for that is that we have the cluster on-prem repository, which kind of supersedes this. Because we had automation for our data center, right? We have an actual data center in the sense of we have a server rack that we use as a local cloud. We run everything through vCenter. So for example, I can show you it here. Hold on. So this is our vCenter setup. And we've got 6 physical hosts, 3 R210 Dell units, if you know your servers, and then 3 R610 units. They're all Dell servers, but essentially we run all of our virtual machines, which is also managed by Pulumi on this hardware. And so because we have other requirements outside of Quirk, we resolve all of those requirements in the main cluster on-prem repository. If we were deploying to the cloud, for example, then we would have one for again, like prod. Right now, prod and dev are actually both in the data center. Sorry, they're both in the data center at the moment because we were doing some changes. And so because there's no cloud deployment at the moment, well, there is in the sense that it's our cloud, not, like another one. There's no individual environment for cluster Quirk. It's just the on-prem stuff. So again, that's just something to note. So what will happen is when I create this new project, we should see something like service Quirk. And actually, this is what we want to do, service Quirk API, right? Because service Quirk is the whole environment, right? Or all of the services, whereas service Quirk API is going to be the service of just deploying the API service itself. So we'll see a new project appear here that's service Quirk API. Um, Jason is such a popular person. Nice. Um, do you care about that info about your environment is on Pulumi servers? Nah, not at all. I mean, Terraform's got all of Hippo's environment secrets. Like, if you know Terraform and how it works, and you use Terraform like cloud, they have every single one of your cloud secrets because it's all stored in a state file essentially. I trust them as a company. I think Pulumi is a good company. I've enjoyed Pulumi very well. As a matter of fact, I think one of the things that like I find to be very neat about it is, I started using it and then I started seeing a lot of my friends liking it and using it. It's just a good product, and as more people start adapting it and using it, and like, it's one thing for me to suggest something to somebody and be like, you try it, see how it works. And then for them to come back and be like, oh yeah, I really like it. And then for multiple people to come back and be like, yeah, I really like it. It was kind of a sign to me like this might actually be something that people will want to use. So yeah. What's up, Jetson? Jets knock. Hello. Okay, cool. So we're gonna say Service Quirk API is our project name, and we'll say service deployment for local development, or we'll say service deployment for development, I guess, maybe. Why can't I go back? That was annoying. We'll try this again. So Service Quirk API. And again, this is a Quirk service deployment for development purposes, right? So this is for development, or we could just say for development. Hit enter, and then we will say that this is for dev. Yep, this is for dev. That makes sense. And so it's going to go ahead and set up all of the automation and everything we need. Yo, Callow, thank you for the 14 months, my man. Appreciate you. How are you? Good to see you, bud. It's been a minute. Hope you are well. Hope to see you at TwitchCon, by the way, my friend. I've been talking to everybody about it because I'm just excited. They haven't really announced anything yet. I don't want to make people think that like they've announced something. I'm just excited. That's all. Okay, so you see this Quirk get API. Interesting. So what we might need to do, honestly, I wonder if this makes sense to do service Quirk API. Like, I wonder if we just need to rename the service repository to this. Yeah, that might be the case. Might be the case. I think that makes sense. Yeah. I think that makes sense. Pulumi. Let's do this. Pulumi stack. Let me shoot. How do I Pulumi destroy? Yeah, there we go. Yes. Oh, it's Pulumi RM, I think. Or remove? Is it delete? Destroy. Hold on. I'm trying to remember how to delete a... Does that go away if I just delete the stack? No, it doesn't. How much do I pay for it? Nothing. Yeah, I don't pay anything for it. I have the free thing. Here, let's just do this. Settings, delete. Yes, go bye-bye. Okay, cool. All right, so projects. All right, let's try this again. Actually, we don't really need to try it again, I don't think. I think it just needs to be service Quirk API, Node.js, service deployment, tsconfig, Pulumi log, package.json, service Quirk API, that looks good. Index.ts. Nginx. Okay, cool. All right, so this is pointing, but where is this pointing to, I guess is the question. I think it's just going to use the current context. Okay, so what we need to do now is we need a Kubernetes cluster. Okay, so I'm not going to go crazy down this road at the moment. There's many different options in how you can do local Kubernetes deployments. There's things like Minikube. If you guys don't know what that is, it's basically running Kubernetes in Docker. No, that's not what I wanted. It's a neat tool that essentially, it'll run a whole Kubernetes cluster in Docker for you. And then it gives you some other options on being able to do things like registries, running registries, persistent volumes, host access, stuff like that. There's another one that I like to use called Kind, which is Kubernetes in Docker, which again is just another Kubernetes in Docker, approach. It's just literally called that. And this is what I normally create Kubernetes clusters with, is using Kind. Again, it's pretty up to you on which one you like. They're very, very similar. And then there's also ones even on the internet that you can use. Believe it or not, you can deploy Kubernetes clusters in a browser, not directly in a browser, but there are websites that you can use completely like through the browser. Can't remember the name of it, but let's see, free Kubernetes in browser. What was it? Does anybody know what it's? I think it's Play with Kubernetes. Yeah. Play with Kubernetes. Yeah, this is it. Post checker Kubernetes. That's not what I'm looking for. Kind with tilt. What is tilt? I don't know what that is. Is it this? No, although KS Lens is cool. I thought it was playwithkubernetes.com. K3 is Rancher. I've tried Rancher. I've not used K3s though. Don't know what's going on. But anyways, we're going to use Kind. I don't know if I have Kind installed though, so I don't. So what we're going to do is we're going to go to the old dot files really quickly. If you do not know, chat, if you do not know, and I'm actually going to be sharing some more information about this soon, but I manage my whole dot files in an Ansible playbook. I'm a fan of Ansible. I like using Ansible quite a bit, and so I use Ansible for a lot of things. And again, one of those being managing my whole dev environment. So whenever I install something on my computer, I don't install it by just doing like sudo pacman whatever, right? I add the automation to Ansible, and then I run Ansible to actually install it. So I need Kind, and to do that, I think I can use sudo. Let's see if pacman's got it. Kind. Yeah, it doesn't. Okay. So we should be able to do Kind. Okay, so it's going to say Kind and Kind bin. If we want just the binary, we would do Kind bin, but by default we would just do Kind, and we'll just do Kind. That's fine. If you don't know, Arch Linux uses multiple package managers. One of them also being AUR, which is really just cloning the latest version of a repository and then building it locally and installing it for you. It's really nice. It's a really nice package manager, and it'll give you really, really latest packages. That's what I'm going to install Kind with. So we're going to create a directory called Kind in our roles. We're going to create another directory called tasks in that one, and then we're going to create a file called main.yaml inside of that. And so now if we go into our Kind tasks and we just search for another one, for example, so AUR, sure, JSON.NET, and we just paste this in. Like, this is how simple it is to automate my stuff. Again, I know you might be saying like, I would never do that. It'd be way too much work to like automate my dev environment. I mean, I'm just copying a line of code or a few lines of code, pasting in what I need, and then running it. It's not that bad. And again, mine is actually much more complex than it really needs to be. Like, what I'm doing right now isn't something I really need at all. It's just something, or you need at all. It's something that like I'm just doing for my own personal reasons. It's all in my dot files, by the way. You can do !dot files in chat and read more about it. And like I said, I will have some other documentation to help you guys navigate it a bit more. But now I should just be able to do Ansible playbook like that, run it, and we should see, there it is. See, Kind is now added to the list. And like I said, this manages my whole dev environment. So this will also make sure that if NeoVim has an update, it'll make sure to rebuild that update. If I have updates for other things, it'll make sure that those things are also updated. See, right now it's actually cloning NeoVim and making sure that it's up to date, which it probably has updates, meaning that we're about to rebuild NeoVim. While we're doing that, let's go ahead and take a look at Kind. So there's another thing about Kind that I do want to point out. When you run Kubernetes in Docker, right, though it sounds really cool, there's not a bunch of stuff you can do with that because it's Kubernetes in Docker, right? Meaning it's just running in a singular container. It's not highly available. It's not scaled out. It doesn't have a bunch of like other interfaces or other plugin support added to it, things like that. None of that's there. It's just a very, very simple bare bone Kubernetes cluster where you can start deploying things if you want to using Docker. There are a couple of things that we really do need to verify and guarantee that we can run our Kubernetes cluster the way that we want to. And if you've ever run Kubernetes before, you might know about, again, things like load balancers or like how do you do like IP addressing, things like that. There are some open source options to making it so that you can provision virtual IP addresses onto your network and have them be accessible, which makes it more of a workable Kubernetes cluster. There are other options that you can use as well to make, you know, your cluster exposed to the network and things like that. So you kind of have to explore how you're going to do that, how you're going to approach that. I already know because, like I said, I've already dealt with this before, so I entirely know. So look at this. Kind is now installed, and so I should be able to do Kind help. Hey, look at that. I can create Kubernetes clusters, Docker container ls, and then we'll do Docker system prune. Get rid of everything. Make sure Docker's nice and clean before we do anything here. Okay, cool. So, okay. So now that my Docker's all cleaned out, let's talk about, again, that requirement. The main requirement that I have is I need a way of provisioning virtual IP addresses for load balancers. I use load balancers for a bunch of different parts of the application, and so there are times where I need to be able to make a public IP address in my, and by public I mean just in my network. I'm not talking about like, you know, on the actual internet, but I just mean like if I want my laptop to be able to curl, you know, my virtual machine or vice versa or something like that, I need a IP address on the network to be able to do that. And so we're gonna make it so that Kubernetes can do that for us. Now, what we're looking for is here it is right here. So the TLDR on this is that we need to tell Kind, Kubernetes and Docker, reliably what is the address pool that it is going to need to provision IP addresses in. And what that means is, like, for example, if you are on a 192.168.0.1 network, right, and your IP address is 192.168.0.5, right, and you want to tell Kubernetes, your local Kubernetes cluster, to provision, you know, 192.168, you know, 0.7, right, then you could tell it, hey, this is the address range or whatever that I want it to provision over so that it's accessible. And we could do the exact same thing here. And what's neat is you can kind of use this in a few different ways. You can use it, one, with the Docker network that comes with with Docker itself, which is a private network to just your machine. Or you can do it with a public network. You can do it just with you know, a network outside of your computer. For right now, we're only going to do the internal one. We're not going to worry about trying to provision IP addresses on the current network just yet. We're going to have to do that, but it works exactly the same, and it just is literally just the changing of what addresses you want to provision. So it's a very, very simple change. But for now, what I want to do is I want to show you guys how to get it working so that it's all isolated, and, you know, if you wanted, you could just run everything on a virtual network. You wouldn't have to know, like, okay, what IPs are available on my current network and blah, blah. I can just, show it to you with the Docker version. So hang on one second. Okay. So Docker has a very nice configuration file option, essentially, that allows you to configure Docker and give it predetermined values and things like that. So that, for example, if you wanted Docker to, create addresses in a certain address space, or, you wanted Docker to use build kit or these other things, then you could do that. And I actually have those things enabled and set up in my Docker configuration. So before, when we say, okay, well, what is the address range that kind can know about to provision IP addresses? This is how you tell Docker what you want that address space to be. So this, for me, is 172.180.0.0/16 and size 24. So I'm just saying, like, hey, I just want to give it 24 IP addresses, or no, 255 IP address. Wait, no, 24. Yeah, 24 IP addresses. And so, anything else is just experimental, whatever. But the main point here being that, again, like I said, I want to make it so that this is the address pool that we're provisioning into right here. Cool. And so, yeah, they're 24 CIDR, meaning that each pool in the 172.1.8.16 namespace will have 250, what is it, 254 IP available, something like that, 245, whatever, I don't know. Anyways, okay, cool. So I think I've already got this, actually, now that whoa. I do not know what that was doing. So cat Etsy Docker daemon. Okay, so we don't have any type of configuration for Docker, meaning that the configuration I have here is not standardized. Now, what that would mean for me is that I need to standardize this really quickly. Now, I actually do install Docker with Ansible. So all I need to do is copy the configuration over and add it to my automation as well. And we can do that very easily. So we're going to go to Docker. We're going to create a new directory in the Docker roles directory. And I don't know if I want this to be files or if I want this to be a template. Let's make this a template for right now. So I'm going to say templates. And then what we'll do is we will go to Docker templates, new file, and we'll say daemon.json. Remember, the whole reason why I'm doing all of this is because I automate my dev environment. So I'm making sure that I have this in source control for later. See, that did not do what I wanted it to. I was worried about that. So default, come on, man. Really? You're not going to copy for me? You should be able to copy. You're going to, yep, you're just going to keep giving me that. Okay. Let me see if I can do this really quickly. Copy this. Nope, that is still not copying. Okay, default address pools. Let's just define it ourselves, shall we? Default address pools, and then it's an array with an object inside of it. Oh shoot, let the music stop playing. And an object inside of that, and then what do we got? Base and size. Oops. Base and size, and we know that the size is 24, right? And then I think it was 172.160.0.0/16, or is it one? It's 1.8. I bet you it's 1.8. It's 1.8. 1.8.0.0/16. Yep. And then I could let's do this. Experimental. True. Size is an int. Oh, is it? You're the best. Seriously. You guys are the absolute best. 24. Okay, experimental. Did I spell experimental right? E-X-P-E-R-I. Yeah, it's spelled right. And then I think there's another command there's one I kind of want to enable, which is I think it's like build. I think it's build kit. Because I just kind of want to enable build kit across everything. And then I think you just do like enabled true. I don't remember though. I don't know if Docker daemon.json. I don't know if that's an actual configuration value or not. Complex Kubernetes environment automation. Automated dev environment with Ansible. Copying a few lines of text. Defeat. That's fair. Hey, you got me on that one. You got me on that one. Okay, so we're looking for build kit. So there's experimental, right? Dude, I'm like 90% confident that there's like a build kit. Features build kit true. Thank you. Appreciate you. So it's features build kit true. So we'll go down here. Features build le kit. The build kit. We will give it the true. There we go. True. Features build kit true. Is that right? That looks good. Gotta love the JSON syntax. I mean, I'm just also a terrible programmer, so. But I appreciate it, Billy. Yo, Mike. Yo, thank you for the follow, dude. Appreciate you. Default address pools, experimental true. Awesome. Okay, so we got our automation file at least. We can go back to our task now. And I already have a copy in my automation for it somewhere. Yep, here we go. Right here. So what I can do is just, oops, that's not where we wanted it. Docker, sorry, tasks. So add to group. There's our copy. Except for it's not going to be init.lua. This is going to be daemon.json. And then what we want is this to be /etc docker daemon.json. Oh, wait, except for not the copy part. Why did you do that to me? You were doing so stinking well, tab 9, until you did that. And then the source is going to be... Oh, you know what? I'm a big old dummy. This is a template. Should have grabbed a template. It's pretty much the same syntax, though, to be honest. Like, look at that. It's almost identical. Would you stop? Thank you. Daemon.json set. I guess. Copy. Sure. Destination. Again, this needs to be /etc docker daemon.json. Jason, where are you? Calling Jason. Daemon.json. Okay. So that looks good. We are now copying from our template directory of daemon, right? Daemon. There it is. Daemon.json. There he is. Good old Jason. And then we are copying it to source. So we're going to need to become the Almighty himself. And by him, I mean, well, not him, her, you know, whomever. Should be one specification on root. But we need to become the Almighty root, the Almighty, themselves. And that will allow us to copy docker daemon.json to its path. Okay, cool. So that looks good. What else do we need? We need a hook for a service restart. That's what we need. Do I have any hooks? I don't have any hooks. I haven't implemented hooks yet in my Ansible playbook. Now, if you don't know what hooks are these neat little things that you can do after things run. And so what you do is you create in Ansible. So we'll go back to Docker. So where we have tasks and templates, we do another directory and call it hooks. I think it's hooks. And then anything in that we can use as variables Oh, is it handlers? Oh, it's handlers. My bad. See, yeah, it's handlers. Good call. Handlers. Sorry, using the wrong name. Handlers. And then we can use these handlers later on when things change. Good call, by the way. Appreciate that. Sorry about that. Controlling when handlers run. Right. So handlers restart using variables with handlers. Restart, blah, blah, blah. So restart web service. So here's our handler right here. Built-in service, right? We could literally copy this because it's pretty much exactly what we need. So we're going to create a file in handlers called main.yaml, right? And then in handlers, we're going to paste that in. And then we're going to say not restart web service, but restart Docker service, right? And so because this is actually just using built-in service, it'll use the native one to the host. We don't have to change that. We can just say Docker and state restarted. So what this is a nice little tool or a nice little handler, I guess, that I can reuse later. And if I wanted to make it easier on myself, I could do something like restart Docker. And that's the handler name that I can reuse later on. So let me show you how that works. So again, there's my handler. Okay. Cool. Okay. So what we're going to do is we're going to go back to our Docker task and we're going to say, we're going to go to that copy daemon.json that we just added, right? What we're going to add to this, because we want it to do something when this changes, is we're going to add a notify value to the key value configuration here, right? And that notify is going to be restart Docker. And so what's going to happen is when Ansible runs and this is changed, it's going to tell Ansible to notify the restart Docker handler to trigger at the end of the playbook run. Now, it's not going to restart it right here in this moment. It's going to notify Ansible after everything is changed that this is one of the things that needs to restart or needs to trigger after it's run. So that's kind of the thing to point out there is it doesn't restart it right then and there. It's going to restart it after all of the changes have been made. Restart Docker. Okay, restart Docker. Looks good to me. All right, so let's give this a shot, shall we? Now again, this is already in a in a role that we have. You need to remove that stance. Oh, do I? Really? I don't think so, right? Because tasks, for example, well, maybe. Actually, you might be right. Hold on, tasks. Yeah, you know what? You might be right. Although I think that would mean we would still need this. Yeah. We'll do. I have a feeling this is going to work. I have a feeling maybe both will have worked, but this is better convention, right? I agree with that. Okay, so that should work. Okay, so like I said, we've already added it to an existing role, which is our Docker role. It should copy the template file from there it is. So you can see before there was nothing in that file. We then copied over our configuration and changed it. That means that it should notify the restart to happen. Now, again, it hasn't restarted anything yet. Nothing's been restarted yet, but it will be after it runs through everything that it needs to. Oh. Oh. Interesting. Hold on. I don't know if I remember this development box's root password. It's interesting that it's asking me. I think I'm missing something maybe. I think maybe, is it sudo? Become sudo Ansible. Hold on. Become true. Yeah, so that's what I thought I did though. Well, no, I think it's either yes or true. But yeah, I definitely did it. What we can do is rm-rf etc docker daemon.json. Oh, shut up. It seems like it copied it though, right? Oh, it was the restart. Oh, we didn't add it to the handler, chat. We didn't add it to the handler. Okay, that's my bad. We'll say yes. Yeah, we forgot it. No. Yeah. Yep. I got you. We forgot to add it to the handler. Yep. Okay, cool. Let's do it. Thank you guys. I appreciate you so much. I knew that. I was testing. Thanks, Billy. Appreciate that, man. I appreciate you. I do. All right, so that's okay. All right, so this should work this time. Terraform Azure Client. There we go. Running handler. Hey, there we go, chat. Look at that. So like I said, the handlers get run at the end. They just get notified that they need to run whenever these things happen. Cool. So now if I do Docker, what do they say? They say this inspect. Oh, there's no network called kind. Yeah, that makes sense. We haven't created the Kubernetes cluster yet, but that's okay. That's okay. Don't worry about it. What we want to do now is we want to create the Kubernetes cluster, but we want to create the Kubernetes cluster with our API spec that we have, right? There's another thing we want to do, which I think is kind of helpful. And that is if we go back here, and I got to be kind of careful with this thing. If we go back here on this old computer, we'll see that I have a config kind right here. See this right here? This config kind is what sets up Kubernetes with kind to be able to take in things like ingress, container port mappings like 80 and 443 and stuff like that, so I can set up ingress controllers. And so what we need to do is we need to provision the cluster. If we go back to here, you'll see here, config map. Oh, this is for metal LB, my bad. But we need to configure and create the cluster with that configuration so that metal LB will work and be able to expose those IP addresses. I think yeah, here it is. It's this one in the ingress. So you see this setting up an ingress controller? This is required for us to be able to do this. So let's go ahead and copy this now, this configuration. And again, all of this is so that we can run Kubernetes clusters that have exposed IP addresses. If you have no desire of doing any of this, then really no need to worry about this at all. Okay, so I wish there was a way to have like multiple configuration files in one place for kind, but there's really not. So let's do, this isn't really something I need to even copy. It's really just something that needs to, how do I want to make this work? If it's in my dot files, then it's always there. So I guess it makes sense to, for starters, always just have this here. Or what might make more sense is for us to turn this into like a shell script, maybe, right? Like if we go to ZSH RC, right? We could make this as like a an alias. That could be neat. That could make things a lot easier. So like down here, here's our aliases. Just don't know if this would work. Can you do like multi-line aliases? I don't know if that's a thing. Bash multi-line alias. A function? I guess it could use a function. There's a shell function rather than alias, yeah. So if that's the case, then it would be like kind. What would I do? Kind C maybe? I don't know. Whatever. Like that. And then local command. I don't know. I to be honest with you, I've not done this in a while. Command equals does this kind of work? Oops. Cluster config. So they're piping. I see. Okay. So it's this whole thing. It's this whole thing. All right, let's do this. Go here. Add all of that. Do this. I think this is right. Yeah, I think that should work. And then I just want to eval that basically. Eval command. Is that how that works? I don't even remember. Is that how you do that? Something like that? That's how that works? Cool. Kind up. But you can just emit eval and command assignment. What do you mean? You mean I can do like emit here? Just cat uf. Oh, I see what you're saying. Just use cat naturally in the function. Yeah. I gotcha. Yeah. Cat uf kind. Oh, this down here. Good call. Yeah, that works. So that's all we need, right? Because I can do n. Yeah, okay. All right, so I need to, now that I did that, ZSH RC. Okay, now that I did that, kind. We'll say kind C. Yeah, we'll call it kind C for now. I need to run my playbook again, right? Because that's in my automation. Let's run the playbook really quickly. And I just really needed to go that far. That's literally it. We don't need it to go too much far. So now if I do kind C, hey, there we go, chat. So again, why did I spend the extra time doing all those things? Mainly because, like I said, I work on many different computers and my dot files is something that helps me solve that problem. I automate everything that I do. And on top of it, automating it also gave me the time and the opportunity to understand fully what I needed to setting this up properly, right? We had two things we had to do. The first one was configuring Docker so that it set itself up in an IP address space that we knew and expected for kind, right? And then now we need to deploy kind in a way so that it knows how to publicly expose its ports. And then we will deploy metal-LB so that it knows the IP address space that we configured with Docker, right? So all that stuff is being has been automated now. I don't ever have to worry about setting that up again. We're good to go. Failed to write kube config permission denied. Interesting. So there's a reason for that, and that is because we manage Kubernetes in my Docker files. What's interesting though is, oh, I see. It's 0400. Okay, let's do 0600 so that it's writable. I didn't realize that. Okay. Exactly. Yeah, I totally could. I mean, how I'm doing it now is just kind of, I just, do what you just saw. I just cancel it. But yeah. Yeah. Did that do what I wanted? Oh, there you go. Kube control. There we go. Okay. All right, let's try this again. So kind dash help. I think it's delete. Yeah, delete. So delete it. Oh, it didn't get deleted. Okay, cool. Kind C. Nodar exists. Docker system prune all. That's also a way of doing it. Docker container ls. Okay, let's do kind delete dash force unknown flag. Wait, what? Deletes a cluster. Delete. Oh, clusters. Cluster. There we go. Oh, it's just kind delete cluster. Okay, cool. Kind C. Let's try this one more time. It should work this time. Go here really quickly. Added kind. Added the Docker stuff. I don't think there's anything. No. Yeah, there's nothing in here that would make anything too crazy. Yeah, cool. So C feature roles. Add kind. Add kind is not a valid branch name. Oh, I was making a branch. Whoops. Okay, cool. So let's do this. Let's do K9s. And I should now be, there we go. I'm looking at my new Kubernetes control plane. And so you can see here, I know because my context is kind, all that kind of stuff. Basically, we're looking at our kind cluster. Awesome. Okay. So what have we done so far? So when we started the stream, we talked about local development with Kubernetes. We spent a lot of time sitting down and talking about the parameters. What can we use? What do we need? All of those types of things. After that, we actually created a new document also called Pulumi Resource Libraries. If you do ! Today in chat, you can see the first document, which is the local development one. And I will be posting the Pulumi Resource Libraries one as well. But we also then, installed kind. I set up my Docker file so that I could have all of my automation with it, my dot file so I could have all of my automation with it. And now I have a Kubernetes and Docker cluster running, and I can do like kube control, deployments, Kubernetes, get, deployments -a. And you can see, there we go, my two deployments, my kube system for core DNS and my local path storage. Yo, Stoop Kid, what's up, man? How's it going, buddy? Using Notion now? Yeah. I needed something that had a really good global syncing option, right? Like being able to sync to the cloud and have that everywhere and stuff. And Obsidian just couldn't do that very well. make my screen a little bit louder, or a little bit brighter. Anyone encounter a bug glitch with Vim before where slash function is blinking really fast, shooting? Oh no, that sounds like a plugin though. To be honest, that definitely sounds like a plugin of some sort. Okay, cool. So let's talk a bit about what we've got and what we can use. Now, remember, in our document, we talked about with our local development that if we need to, before we try deploying any services, we need to be able to support running our existing like cluster stack, right? So hold on, where is it? If we decide to support multiple services, we could say if we decide to support multiple services in development, then the cluster quirk automation will also need to be run locally for required services. And so those are things like Knative, ingress controller, etc. Now, when I said earlier, when we were using kind, right, to like expose IP addresses, use load balancers, etc., there's another step to that process besides just creating the Kubernetes cluster, and that's deploying the Metal LB open source deployment that handles the creation of all the IP addresses and all that kind of stuff. So there's a piece of software that we're going to use called Metal LB that will create the IP addresses for us in our Kubernetes cluster. And that's what this documentation on the load balancer right here says as well. Can you not sync the markdown folder to Google? I mean, you can, but like I want something seamless, you know? Like I want something that's like really easy to use. So that was really a big factor for me. Okay, so let's go to cluster quirk. It looks like we don't have cluster quirk repository. Alt F4. Oh, I do have cluster quirk. Okay, cool. That's weird. Not really too sure why that wasn't there. Okay, awesome. So I have a repository here called cluster quirk. And if you guys recall from earlier, I told you that all of the lower level quirk automation for each cluster is essentially in this repository. So when I said that, hey, to be able to do any type of multi-service deployments locally, right, I need the cluster quirk automation, but because when I created this automation, I can deploy it against local Kubernetes clusters, it's actually very easy to set up. And we already even have a test-YAML that we can kind of inspire from. And so what we're going to do is we're going to do Pulumi stack ls, and you'll see that we have a test, and that's it. Test has really been for entirely just local environments and things that we do, you know, outside of clusters. So I'm going to keep using test for now because that makes sense here. Now, realistically, this is dev, right? But we don't want dev to collide with a dev that we might have deployed in the cloud, right? That's something we don't want to do. So it's okay if we have test here, mostly because there's really nothing binding it. We can use test across the board and it should really not matter too much. But let's go ahead and let's set up our Kubernetes cluster with that automation. So if I go in here and I go and look at the index.js, right? Let's look at the automation that we've got for this. Now I'm going to go ahead and delete a couple things here, but the main focus is what isn't commented, and that is our cluster type, right? So we tell this configuration what type of cluster we're deploying to. It sets up Metal LB, right? Which is our load balancer. It sets up ingress nginx, and then it sets up Knative as well, right? So our automation, depending on the cluster type that we set, should be able to deploy Metal LB, ingress nginx, and Knative to our Kubernetes cluster. So, I mean, it should be like pretty much able to do that. Let's look at Pulumi test really quickly. And so you can see here, we've got a couple secrets in, or a couple values in here: cluster quirk, cluster type, kind. Look at that. I was already using kind. Keel password. We don't need that. That can get out of here. But then our Metal LB secret key. Cool. That all looks good to me. So let's do a Pulumi update. Select our test stack. And then it says, it looks like the Pulumi SDK has not been installed. Have you run npm install or yarn install? No, I have not. Okay. So is this yarn? This is yarn. Okay, let's do yarn. Below description says you're an RPG guru. What sort of stuff do you play? I'm already fangirling and I don't even know yet. Honestly, probably a lot of WoW. I mean, I've loved RPGs my whole life. I played StarCraft as a kid. Then I played StarCraft 2. So I played every StarCraft. I played all the Warcrafts. I got into WoW like release day that it came out. I was super excited about WoW. I skipped school just to play it. And then I played a lot of WoW. I tried a lot of other MMOs and RPGs and stuff like that. I wasn't super ever into I was never really into consoles. Like consoles just weren't my vibe. My co-host, who's behind me, if you want to see him, here you go, ready? Never mind, he's not there. I thought he was behind me. Anyways, his desk behind me. He loves consoles. He's like console king. He's really good with consoles. I just never was. I've always been an FPS player and a PC player. And so yeah, I did a lot more stuff on the computer. So like there wasn't many other RPGs. I know that there was a ton of really cool single player RPGs on the console, like, Elder Scrolls and all of them, like, all of that series, which eventually came to PC. But yeah, no, for me, it really just was a lot of WoW. I got really into WoW. I became like really high ranked in the PvP system and lost a lot of school days because of it. And yeah, you getting on the Lost Ark train? Yeah, I'm already playing. Yeah, I'm already playing. All right, let's do a Pulumi update really quickly. Select our stack now that we've got our packages installed. And hey, look at that, chat. Look at that. So what has happened here? So we grabbed pre-existing automation that we knew and said, hey, this automation provisions things like, again, our Metal LB, load balancer, IP provisioner, our Knative resources, our ingress engine, all of that stuff gets provisioned for us, right? We're getting all of that essentially out of the box here. And so what we can do is just simply configure this for the specific stack, which in this case is test. We're calling it test, and then run it. And you can see that we've already done automation against kind. So this automation knows how to deal with a local Kubernetes in Docker setup. And all of the stuff is ready to go and be deployed to locally. Now, I'm not going to do this just yet because I do want to take a look at one other thing, which is I want to make sure that our Metal LB automation configuration is what it should be. And so let's take a look at this. So you see here, this says this is our config kind.yaml file. Remember how we did 172.18 Well, look at that. This address space 172.181.200.250. This address space is in that address space that we configured Docker to use. So when we deploy this, Metal LB will say, okay, well, these are the IP addresses that I'm going to provision in, and I should be able to access those IP addresses. So that was the other thing I wanted to check. So let's do a Pulumi update. Actually, let's do Pulumi stack select test so that we have this stack selected, and then Pulumi update. Now again, if I go here and then I do K9s, I should, again, be connected to my kind stack. So if I hit yes, what's going to happen is Pulumi is going to start deploying all of the resources, 228 of them actually, to my local Kubernetes cluster. So let's hit yes, and let's see what happens. Also, I want more YouTube content. Don't worry, there's a lot more YouTube content coming. There's a lot more coming. Hey, look at that, chat. That looks like some stuff starting and running. You getting on the Lost Ark train? But yeah, no, I am. I'm loving Lost Ark. It's a lot of fun. Have you ever played any pen and papers, MTA, D&D? Yes, I used to be a dungeon master. Yeah, I love D&D. What was your WoW peak rating? So no, you're fine. When I played WoW, when I was playing PvP, it wasn't a MMR like it is now. It was a ranking system. And I went to Grand Marshal, and then I went to High Warlord on a Warlock. I was obsessed with PvP, so yeah, I did both of those. Yeah, I loved PvP and WoW. I was obsessed with it. Okay, cool. So look at this, chat. Here we go. We have a bunch of containers starting here. One of them's in a crash loop, but that's okay. It'll eventually get out of the crash loop. There you go. See, it's running. And all of our all of our low-level resources that our cluster needs or our services need to run are being deployed right now. Yeah. No, I played WoW release day. Yeah. Oh, that's not pathetic. I mean, anybody who tries like playing a PvP style game is tough, man. There's a lot of really good players out there. So Pulumi has created most of the resources already, which is awesome. And here goes the rest of our Knative eventing deployment now. We should see a bunch of eventing stuff popping up here. So Knative serving. We should see Knative eventing popping up here in a second. Oh, team player. Being a team player definitely helps. There we go. There's the eventing containers. Probably not now as much as I would like to. Oh, thank you. Appreciate the brewski. Yeah, I mean, what I can tell you though is that we want to do something like that here. Cheers, by the way, chat. We want to do something like that. Yeah, it'd be super fun. Okay, cool. There we go. Okay, so it looks like everything got deployed successfully, right? 228 created, 2 minutes and 57 seconds. Oh, that'd be awesome. Yeah. I mean, more people that are interested in it will just be part of the reason why we do it. So, yeah. If you'd go the second route and create separate repo per Pulumi module, would you open source some of them? I mean, I've considered open sourcing a lot of this, honestly. Like, there's nothing about this repository. Like, there's nothing about the actual service quirk repository that you can do anything with, right? Like, again, here's all the dev secrets. Like, what are you going to do with it? Unless you have the credentials or I'm a dummy and commit something, I shouldn't. There's really not a lot of things here. Now, there's some like meh kind of things. Like I think, yeah, no, there's nothing in here. I thought like, I don't know, maybe I had like an ID or something, but yeah, no, I mean these repositories are actually pretty secure. Well, knock on wood at least. Excuse me. So they should all be able to be public at some point, but I just haven't fully pulled the trigger on it yet. So yeah. Yeah, no, you're not stupid at all. Don't worry about it. There's no stupid questions here. Open source basically means it's code that is maintained by people for free and is available for free. You don't have to pay for the code or the licensing of it. You can use it with specific agreements that the licensing provides. Okay, so let's do kube control git deployments A. Look at that. There's all of our stuff. Okay, so like I said, we now have a Kubernetes cluster with all of our quirk stuff. And as a matter of fact, if I go in here and then I go to cluster quirk, we can see tests. And if I click on test and then I go to resources, we should see, yep, look at this, a bunch of resources here. These are all of our Kubernetes resources. And this is again just for the test environment, but cool. Okay, so we should be able to now go back to our service repository. Quirk. Wait, where did I repository? Oh wait, that's right. I renamed it, didn't I? Yeah, service quirk API. Okay, and so we're gonna go into Pulumi now. And so here, we have an environment set up. Let's just do Pulumi update. See what happens. So we need to create a new stack. Okay, so we still need to create our stack. So let's create a new stack. We're going to call this test as well. Well, no. This needs to be called dev, technically. I think. Yeah, I think this needs to be dev. Okay, cool. All right, so let's go back to projects, Quirk API. I don't know why it's like doing that like that. I guess it's because maybe I don't have the source code pushed up, or oh no, it's because it's VS Code. Okay, I see why. Interesting. I almost want to, let's do this really quickly. Let's go back to the GitHub Alta4 cluster Quirk. Let's do Pulumi delete. Or no, Pulumi destroy. They might ask, why are you doing this? I think I actually do want this to be a dev thing. Now, the thing is there's nothing in this that makes it bound to a specific environment. Like, even though it's called test, there's nothing about it that makes it like, you know, there's no like prefixes or anything like that that call it test. I guess the alternative here would be that I don't use Pulumi Cloud for what I'm trying to do. So the challenge here basically, Chad, is that because I'm using Pulumi Cloud, I could have collisions, right? Because everything's in the cloud. So for example, if I had two even test environments, it doesn't matter if it's test, dev, whatever. If I have two environments with the same name, I'm going to have a collision. Now for cluster Quirk, that's really not that big of a deal. But it does kind of mean that dev can only be in one place at a time, meaning that, boy, that makes it a little interesting for when I want to deploy this to the cloud. So I think what we're going to do for consistency's sake is we're going to use dev instead of test. Yeah, they can reject your pull request. Yeah. I think I'm going to use dev instead of test for it. So we'll create a whole new stack. And then we'll deploy service Quirk API, or at least it's a very simple deployment with dev as well. The idea here is that we want to keep this consistency rather than have really weird edge cases and then have to go back to it later. That's essentially what we want to avoid here. Yeah. Okay, there we go. There's all of that stuff. How long are you going to take to delete? There we go. Okay. So while that's doing that, let's go back to cluster Quirk. And then I should be able to do Pulumi stack -- help. Pulumi stack, init. And then the init, the stack name will be dev. Yep, it'll be dev. Cool. Pulumi stack ls. Pulumi refresh. Or no, we should be able to do Pulumi update. Like, I should just be able to run this now. Cluster Quirk type. Okay. So Pulumi config set cluster type. And this will be kind. We want it to be a kind cluster type. And then I think if I run it again, I should get one more error, which is, yeah, my metal LB secret. So this really doesn't matter, but because this is still kind of like dev, I'm not going to share this with you. And I'm going to create a script, but I will show you everything that essentially I'm going to do. So we'll do config, set secret metal. Wait, what is it again? Metal LB dash require secret. Here it is. Metal LB secret key. Okay. So metal LB secret key, and then whatever this value is here that I put. Yeah. Thank you. Appreciate that. Okay, so again, the only thing that's going to be different here is just I'm going to be putting in encrypted value in there. So give me 1 second. Cool. Okay. So now if I go to dev, there we go. I've got the two values populated. And so now I should be able to do Pulumi update. And there we go. So on the right hand, I have all the stuff being deleted from the cluster. And on the left hand, I've got everything to be added to the cluster. I'm not actually going to run the new Pulumi update just yet because I want this one to finish before I do that. So let's just open up K9s really quickly, see where we're at. Looks like we're still kind of in the middle of deleting stuff. Yo, the Spes took, I guess. Thank you for the follow. Appreciate you. 728. Oof. This is taking quite some time. So it's down to... Oh, it's almost done, actually. It looks like it just has Ingress, Nginx, and Metal LB left. Might be close. Help it? With what? Like just like force deleting stuff? I'm good. I don't like forcing an orchestrator to do something it doesn't want to do yet. It normally pisses it off. Come on now. It's just because it's probably waiting for some like admission webhook or something like that. Something weird to finish. There we go. We can flip them. Yo, Rakondo, 37 mother flipping months. Dude, Jesus, Austin. Rakondo, what's up, buddy? How's it going, man? How are you? Thank you for the 37 months, dude. Rakondo is one of our first subscribers ever. Crazy. 37 months, bro. Oh my gosh. That's a long time. There we go. Okay, so Kubernetes, Metal LB should be going next. There it is. Like it when the numbers go up. Yeah, I know, right? Come on now. Go away. All right. Everything. Hey, there we go. All right, cool. So everything's done. The test stack is empty. We can now run this again on dev. And this will create the dev ingress and all that stuff. Okay, cool. So... All right, so if we go here, we go to cluster quirk, I click on dev, I can actually watch this in Pulumi, which is kind of nice. This is, very similar to Terraform Cloud where you can watch, things as they run. Now, again, this is me running it. Like this is the only thing that kind of makes this a little bit less meh is I'm running it, right? This is my own runner. So Pulumi doesn't have native support yet, at least from what I know, with regards to cloud runners. They run everything, or you run everything basically. So yeah, this is me running that, running that locally, and then the output being published to Pulumi. Hello. Oh no, he does not like that at all. He is not a fan. Yo, Codemaster, thank you for the follow. Appreciate it. He did not like that. We almost done. So the API service itself is going to take a lot to deploy. So what I'd like to do to wrap up, because I do have to kind of get going here very soon, is I want to deploy just a basic service and then show you guys how we are able to hook into the cluster quirk stuff with that really simple service. And so what we're going to do is we're going to deploy the Nginx service, and then we're going to make it so that we can actually access that thing locally, or we should be able to at least. And so then again, the whole point there is that we're testing to make sure that the server or the Kubernetes cluster is running, right? It's configured properly. The lower level cluster quirk services have been deployed properly. And on top of that, the service itself has been deployed and we can access it and, do that. Did you ever go over quirks? So I've not actually done that in a while. That's going to be like a whole other YouTube video. I can show you a quick little, I guess I could show you like a quick little, no, I can't. It's all new. I actually can't. A lot of it's new and changed. So unfortunately I actually can't, but I will be making documentation on that soon so that you guys can check it out. Don't worry. Okay, so let's go into our service repository. So like I said, if I do K9s, right, this is all of our lower level cluster quirk automation. This is all of the stuff that everything in our Kubernetes cluster that all of our quirk services need to run has been deployed. If I go to service, for example, okay, see this right here, 172.181.200. I should be able to go to this in my browser. And look at that, I can. This is what I meant by making sure that all of these things work, right? As I told you before, if we can visit an IP address like this and get Nginx, then we're hitting our ingress Nginx service. And if we wanted to, we should be able to go to here. I don't know if we're actually going to get... No, we're not going to get any actual values. But we would be able to, if we had maybe like an ingress controller or a different type of logging, we should be able to see those requests coming through. But this 172.181.200, if we go back to our service list, right? Look here. That is this this service right here, which is our ingress Nginx controller, right? If we go to 201, we go to courier, right, which is for Knative. So it looks like our IP addresses are at least routing properly, like our DNS is routed, or I'm sorry, our actual networking is set up properly. So let's do this. Let's go to our service repository now, right? Remember, this repository is where the API source code itself lives. We're not going to deploy the API itself because it's just a very complicated service and requires a lot of configuration, but it's identical in the sense of like what we need to do, right? Which is we just need to create a deployment for this and make sure that, some of these things are working before we start. The only thing that's going to change is the deployment configuration. That's it, really. It's still going to be a deployment at the end of the day. It's still going to have labels and replicas. It'll still have, environment variables and all of that stuff. None of that's really going to change, just like we say in our spec here, right? What we discovered or what we decided was, okay, well, this is all the stuff that we need for the current setup, right? This is everything we need for the current setup. Let's just replicate that locally. That's all we're really doing here, chat. And that's something I really, really want to point out here is even if I stopped the stream right now, you should be able to walk away knowing that what we decided to do our local development for Quirk was to use Kubernetes instead of Docker Compose and to use Pulumi instead of Docker Compose to deploy those local services. And everything else a part of that is just details on how that works, what's required of it, and stuff like that. But in the bare bones, very simplest approach or very simplest, way of explaining it, all we're doing is creating a local Kubernetes cluster, taking the automation that we run in the cloud, making it be able to run local, and then also creating individual automation for each service that allows us to deploy only that service locally, right? Not the whole cluster. We're not talking about, oh, I want to deploy, every service and everything that's needed. All we deployed was our low-level services. And again, these services are not Quirk services. These are things like, again, Knative eventing, our ingress controller. When you work with Kubernetes, you know exactly what I'm talking about, right? Anybody here who's worked with Kubernetes long enough knows that there are resources that exist outside of your application tier, right, that are still a part of your Kubernetes cluster that require automation. And this is basically all of that automation. That all got deployed, right? And then we say, okay, cool. In my source code for my application, the API in this case, again, look, we do pwd, we'll see service quirk API. There's a Pulumi directory, right? And in this directory is the automation so that I can only deploy, right? Only deploy the API service to a local Kubernetes cluster. And this deployment should have the same parameters as the cloud one in the sense of the same resources as the cloud one in the sense of it gets a config map, it gets a secret, it gets load balancer, it gets all that stuff, except our configuration will be managed by Pulumi in a way that it'll know how to communicate with the cloud, right? It'll be configured to make requests against the other resources in the cloud. And then when we go to the cloud, we can point it back to our local environment if we want to. And so that's how we're tying these two together, where we're saying, okay, first thing, you got to set up your local Kubernetes cluster. Boom, did it. Awesome. Okay. Now, any service that you develop with Quirk will need to be deployed to your local Kubernetes cluster and configured in a way that it knows how to go out to the cloud for every other service in that environment, right? So if it's dev, it should know how to communicate with every other service in the dev environment. And again, that's why I say what I'm about to show you in the sense of us deploying this service to the dev environment or our local Kubernetes environment for testing or for development, it's going to be the same, right? Whether it's Nginx or whatever, the configuration is different. And that's what we kind of talk about here in the sense of we need volumes, right? We're going to have to make it so that the deployment mounts the local volume. That, you know how to do that, chat. That's understandable. You understand that, right? You might not know how to do it, but you understand when I say to you, JavaScript is going to have to figure out the path and then add that to the configuration. That's trivial. It's not that difficult, right? But we needed to know that that's what we needed, and that's what this document provides us with, right? So like I said, the configuration will be different, but the resources themselves will be the same. I don't understand anything about JavaScript. That's fair, Teach. I don't think anybody really actually understands anything about JavaScript. I think it's just an assumed really bad nerd hierarchy that people just somehow fall into, and I don't know. I don't really know anything about it. How you doing, Teach? What's up, man? Shout out to Teach. Hello. I will say though, Teach, I actually enjoy managing my infrastructure with TypeScript. I do enjoy that quite a bit. I don't know. I have fallen into the TypeScript bandwagon. I do like TypeScript. I like types. I don't like ripping my hair out because of weird issues, Yeah, I don't know. I'm good. I'm glad to hear that. Okay, so like I said, Kubernetes cluster's up. Our deployment is ready. And again, all we really need to do is imagine that this is our API service that we're deploying to our local cluster to point to the cloud. It's going to be an Nginx service for right now, but isn't really too much outside of that. Okay, so let's do Pulumi update. Pulumi stack select dev. Pulumi update. There we go. And then yes. All right, so here's what's going to happen. We should, yep, there it is. There's our Nginx deployment. Right now, there's a couple things that I want to kind of point out here already, which is we deployed Nginx, but it has no real isolation to dev or, no real concept of that whatsoever. So let's make a couple changes here first. Let's do this. Let's go to here. And let's create a namespace. We're going to say const namespace, right? Equals new k8 dot core dot v1 dot namespace. This will be dev nginx, right? Because it needs to be in the dev environment. And then we will do metadata, right? Because that's essentially the good old Kubernetes spec. Name, and then our name will be dev nginx, right? So if I wanted to make this even easier, I could say dev nginx right here, right? And then I could do this. I gotta stop doing that. Here, and then do app labels dot app. There we go. Delete this. Oh, that's right. I remapped that. App labels dot app, and then for consistency, app labels dot app. Cool. Okay. So now when I redeploy this, update, we should see this actually get redeployed from default into its own namespace. So it's going to create a new namespace. It's going to create a new deployment, or it's going to create, well, actually, it's going to create a whole new deployment. It's going to delete the old one because the old one's in a different namespace. So let's go to here and, oh, my bad. I missed something, which is I forgot to put it in the namespace. So metadata labels here, we want to say, oh, wait, is it here or is it here? Yeah, I think it's here. I think this is where you want it. Yeah. Oops. Hold on 1 second. Sorry, 1 second. Namespace. Is it namespace? Yeah, and then namespace dot metadata name. TypeScript is pretty good language. Ecosystem is what makes it complicated for me. I do not understand the things that happen outside of files, but TypeScript as a language is pretty pleasant to do. Yeah, I agree. No, I totally agree with that. All of what you just said. Is that going to dev nginx? So it's going to put the deployment in a different namespace. There it is. There you go, chat. So see dev nginx. Now we have a dev scoped nginx service. And I can do this really quickly. If I do context and then I do Kubernetes admin Kubernetes here, we should, wait, what? Kube control git config. Is it config? Wait, no. Config git context. So kube control config set. Wait, no. Use context. Sorry, use context. And then this long thing. And then canines. Weird. Why can't I access my... All right, I'm not gonna worry about that right now. Canines. Oops. Context. And then we'll go back to kind. Oh my gosh, I'm a dummy. Is that really what it was? There it is. Okay, I'm a dummy. Okay, so if we look at our Kubernetes cluster in our data center, in the garage, you can see here that all of them follow this convention of like dev dash, right? Dev dash bot Discord, dev dash Cloudflare. We made a decision, a design decision with Quirk to isolate every service in Kubernetes in its own service namespace, right? Like the main scope of everything is the service, really. And so what I should be able to do, again, if I go back to context and I go to kind, is have that same thing here. And we do, actually. If we go to dev dash, we can see I have dev dash nginx. Like I told you, there's really not going to be that much of a difference in the sense of the resources that are there. It's just their configuration that's different. That's it, right? And so at this point, what I can do is, I can reconfigure the deployment so that it's using the node image that we discussed, right? So if we go back through here, what would be different, right? We deployed it. What would be different? Well, we talked about environment variables, right? So we would go into Pulumi and we would set up the environment variable injection. We would really, ideally, do exactly what we're doing in the main service automation, right? Where we would, create our app labels, create our namespace, create our config map, create like this whole file here that already deploys the API. And this is why I'm saying we're not going to do this right now, because you can see the API has a lot of configs. It's got Postgres information. It's got Azure client, bot client, consumer key, Postgres password, like all this other stuff that I just don't feel like configuring right now. But again, we can rely on our document to ask ourselves, like, how will this look, or how are we going to get there? And again, it's very straightforward. We've already set it up so that we can set up our local Kubernetes cluster with everything that we need, just like we have in our spec, right? And then on top of that, we made it so that we have a new repository that we can deploy from that allows us to deploy these services individually. Now, the questions that we don't have solved for are, well, how do we make sure that those, are consistent, right? And that's where the Pulumi resource libraries come into play. Now, we didn't investigate that tonight because I think that's something that could be investigated at a different time. But if we talk about, wrapping a bow so much on local development with Kubernetes, I think this is a go. Like, I think this is perfect. Again, in the cloud, we use Pulumi with Kubernetes to deploy our services and all the infrastructure that's required. We do the same thing in dev, right? We use Pulumi to manage all of our secrets. We do the same thing in dev. We use Kubernetes to, do all of our container runtimes and, image management, all of that. We use the same thing in dev. Like it's the same everywhere. The only thing that's different is just where some of that automation lives, which is why, like I said, we will need to investigate the Pulumi resource libraries further, but I'm going to do that on my own time. And then I will come back with my, my findings. So yeah, chat, I think that's a good point, a good stopping point. I've been going for 4 hours, which is a little bit longer than I meant to. But I think we got a lot of really good work done here. And I think, again, we should be able to leave all of us with the understanding of kind of what the goal was and how we got there. Also, if you don't know, like I said before, yo, Alan, I'm so sorry, buddy. Yeah, I am about to call it. If you don't know, here's the cool thing, Alan, and I want to say this to everybody. We released something called the Alt F4 Wiki. This is a new project that I created for the community, and the whole idea behind it is if you ever miss anything, if you ever have questions about something, if you ever want to share something, this community wiki is what that's there for. I'm posting all of the documentation and everything that I generate on stream in the wiki. And so, for example, if you go to the Alt F4 Wiki, you're going to see a few categories at the very top level: technical documents, Twitch streams, DevOps and infrastructure, staff, all that kind of stuff. I didn't get the opportunity to do my notes for today, so I will make sure. Actually, I can kind of do those right now. But the main TLDR is that every stream will have a notes right here where we also include the VOD for it. And then you can kind of see like what we did, what we talked about, any documents that got created through that. And like you don't miss anything. So here, just for you guys, so that you guys can reference this later, let's go ahead and do that right now. So this is page, what's today's date? It is 02. YoBG, can you tell? Yeah, Tej says hello. What up, Tej? I don't know if you heard him, but he squeakingly said hello. So this is 12:22. Okay, so let's talk about what we did today, right? So let's talk about today's agenda, right? So we started by talking about needing the ability to develop locally for Quirk. And we could say this was becoming difficult to do, which was discouraging to working on the project. The main issue was how Docker Compose works compared to something like Kubernetes. Certificates and other non-string value secrets are managed very differently, which introduces different design approaches to the problem. Because we want consistent service configurations and deployments, it became likely we would not use Docker Compose for local development and rely on something else. So then when we started talking about that, we created a new technical document called, and this is where we link to our new technical document, right here. Local, what is it? Local development with Kubernetes for Quark. Local development with Kubernetes for Quark. This outlines the goals for local development using Kubernetes, how existing deployments work with Kubernetes to the cloud, and then what would be required to do local deployment or local development environments that, and here's the tricky part, that integrate with cloud environments for hybrid service availability. And the TLDR on this is if we are working on the API locally, services in the cloud should be able to, services in the dev environment in the cloud should be able to access that local API container, right? Okay, so we created a technical document. We could say more information outlined in the hybrid, and this is another document we have. This is why I did this. Hybrid feature environments, hybrid feature environments, which outlines or more information outlined in the hybrid feature environments topic, which details how all of this works. Cool. Okay, so that was really a lot of today's agenda. Oh, I guess we also, what else did we do? We also deployed our cluster Quirk automation, right, to a local kind cluster modified for running our stack, right? That was the first thing that we did. And then we created a new Pulumi project within our API service repository for local deployment automation, right? So yeah, that's really it. And then on top of that, we tested this with a basic Nginx deployment, which worked successfully. BG, does Quark do anything with GitHub sponsors at the moment? I'm going to be completely real with you, Tej. I'm going to give you the lowdown right here. Quark has been something that I have just basically built to create and generate content for like 3 years. And through the process of that, people have started using it and depending on it and like actually it became a product without me even realizing. So yeah, no, it doesn't have anything. Like it has nothing, dude. It's been in what we like to call a delayed alpha for about 3 years. And no, it doesn't. And here's the best part, Tej. We recently, if you guys don't know, we did some partnership, like streaming content with Azure. And it was a huge success. It was a lot of fun. We migrated all of Quark to Azure. They're putting out the tweets about it now and stuff, which is awesome. But they're talking about Quark. And so like I'm like, oh god, like we don't need to talk about the actual app, like it's nothing, like, but like I forgot that in the series we talked so much about like it being a platform, because it's a whole platform that has like, you know, a bunch of stuff and whatever, but it's still not like the way it's presented is if it's like this product a bunch of people can use, and it's really not. I would love, and that's really what we're working on so heavily, is this so that we can get to a point where it's an open beta and people can use it, and, you know, more people can use it, right? Like our friends use it, right? Prime uses it. Jordan uses it. You're welcome to use it. You know, Trash uses it. A lot of people use it now. Rocks as well. But it's literally what Pondbase is saying. We got to a circumstance where it just became really difficult to ship Quark quickly. Quark's got 16 microservices on its own because it integrates with, on a very low level, like Discord, Twitch, Twitter. It has like scheduling service, like all of these things that honestly they just need to be dusted off, revitalized, and they're super cool features that like nobody knows about. But yeah, it's gotten a lot more momentum in the past couple months just from the migration and everything else. And so it just became like, you know, Quark is kind of in a way my telescope. You know, it's not as popular. And to be fair, my telescope's really my LSP containers, but you get my point. You know what I mean? It's my passion project that I've loved building and I want to keep growing and maintaining. And yeah, exactly. Yeah. I was chatting with some people on it recently about how it'd be cool to, I'm super interested in GitHub sponsors. And you know, Tej, one of the reasons too why we built Quark was to have a platform that existed outside of Twitch that we could do things on. Before we were a company, it was a lot more difficult to kind of do, I think, some of the more like, monetary sides of things, if you get my drift, Tej, as like Stream Elements has. But you know, there's a real desire to not want to take, you know, or have Amazon take 50% of all of your money, or at least all of your generated profits, you know, and even things like, you know, Patreon or GitHub sponsors or things like that. Yeah, exactly. It is desirable, you know. So Quark in a lot of ways was also built as a, hey, well, Twitch isn't doing this, so let's just make our own. Just like, you know, Stream Elements did. I don't know if you guys know this, but Stream Elements just integrates directly with PayPal. Very simple, you know, nothing too crazy. And yeah, you know, So no, Quark is something that is becoming more of a serious product. You know, Prime has been super gracious and using it a lot for his, like, he's hands down used it the most. He's built it with like 3 or 4 of his own projects he's worked on, and it's been a really easy thing for him to use. Again, we've had other friends use it too. Jordan used it. True used it. I think they both still use it for like all of their alerts and stuff. So it's something I don't want to let go of. It's something I want to keep building, but I needed to be something I actually can build, you know, and work with. And it's like when I went to Hippo and I saw how I can have nice things, and then I looked at Quark, I was just like, oh god. Yeah. Oh yeah, no, yeah, that's literally why we built this feature. Yeah, the story that I'm sure Prime loves to share is there's a feature in Quirk that was made just for him, which it's true, it was. When we were first building Quirk, I was like, yeah, like I'm somebody who's very much like, if I can get hype behind this, like let's get it, And so Prime was like, yeah, I'll use Quirk. I was like, awesome, okay, cool. And then she's like, how do I generate tokens? And I was like, I'll just give you one. And so I just gave him one, not realizing that, yeah, he's like the doxing king. And yeah, he basically that next day I think doxed it, and I was like, okay. So I built this whole and it's built in a way that like you can't dox yourself. And this is why again it really was in mind for him, which is when you generate a new token like this, it doesn't show you it. That's purposeful. That's because of Prime. And so, yeah, you can copy the token without ever seeing it, right? Or you could show the token if you want to. But yeah, that was entirely because of that. And again, but it was something also that like any of our streamer friends would appreciate, right? So, him battle testing it for us has been massively helpful. But it's not even that, he uses all of our Discord stuff. For example, in our Discord, we have moderation stuff to where you can get notifications for everything that happens in your Discord. You can get member hello, like be sure to say hello. Quirk does all of that in his Discord. And again, like, human verification. We do all of the human verification for his Discord too. There's a lot of stuff Quirk does, man. It's actually kind of crazy. Anyways, let's get this Twitch stream thing added so that I can go. All right, so today's agenda, chat. Here's what we're going to do. And this is something that we're going to do every stream, which is I'm going to give you guys an article or a topic, is what they're technically called, in our discourse or in our wiki that you guys can use. So we're going to say here, we'll say local Kubernetes development with Quirk. Yeah, it's pretty much that is what it is. Local Kubernetes development with Quirk. Or we'll just say local Kubernetes development. That's fine. Okay, so the other thing we want to do is, and I don't know if you guys knew this, but you can actually get the VOD while we're streaming, which is pretty cool. So if I go here, and then I go to here, this is the VOD from today's stream. And so I can go, oh shoot, I didn't grab the right thing. I need to grab the embed. Settings. Exactly. It is desirable. Wait, Quirk in a lot share. Of ways was also built as a share embed. This, so let's just make our give me the iframe. Just like Stream Elements did. Close this. Paste this in. No, don't do that. You're gonna do an actual iframe. There you go. And then the other thing we want to do is insert a table of contents. Cool. Developers, please check your browser. You're fine. You're fine. We just need to change this to alt f4.wiki. And there we go. All right. And so you can actually see it's playing right now. So the other thing we need to do really quickly is we need to make our links. So let's go ahead and make those links really quickly so that you guys can have access to the other articles. So one of those was the hybrid environments thing. So there's one, right? Oh, did I mess that up? Oh, yeah, I did. Ooh, I did real good. All right, Tej, have a good one, buddy. Again, shout out to Tej. If you guys don't know him, be sure to give him a follow. Fantastic person, very knowledgeable. One of the few engineers I genuinely am always interested in learning, like what I'm going to learn next from. So be sure to go check him out. Let's do this. There we go. Okay, so there's that link. Where's the other link that we need? So create a new technical document. Here's the other one. So let's do this. And back. And here we go. And there we go. Okay, so I think we're good, right? So we've got started out by talking, needing the ability, it's becoming difficult, certificates, created a new technical document, local development with Kubernetes, TLDR. Oh, you know what? We did, shoot. So where's that created? Okay, so cloud environments, shoot, there's one more thing we need to do here, which is right here. We're under this create a technical document. Discovered there will need to be a way to manage Pulumi resources with or resources globally, then import those into automation projects as modules, right? So that's one other thing we want to make sure that we add, which is we'll say we started a technical document on, and then we'll say Pulumi resource libraries, right? Look at what I'm doing for you guys. This is ridiculous. Pulumi resource libraries that will be investigated further and added to the wiki once completed, right? So I don't know if this is something I'm going to do off air or on air, to be honest with you. I really don't, because this is something I kind of need to do. But I'm going to let you guys know about it regardless, so don't worry about that. Okay, so create a new technical document. Discovered there will be a new way to Pulumi resources, Pulumi resource libraries that will be investigated. Clear kind. Okay, cool. Awesome. So chat, check it out. So here's what we do. This is what we do at the end of the stream. We create our new topic, right? This topic is available for you guys. Now, what's going to happen is once this is created, you guys can access this and get all of the information you need from today's stream. This is something that I'm trying to do for you guys so that you won't miss a beat. If you ever have any questions about anything, you can easily ask them. You know, you're 100% good to go. And so what's funny is like, this is the actual VOD. The VOD's already there. It's available for you. You can go through the agenda. You can check out all of the different articles that we created. Again, we created a new one, which was our local development for with Kubernetes for Quirk. That's in the technical design documents section. I will be working on the other one, which is the Pulumi resource libraries. This is at least a preview of it so that you guys can see it. Anyone on the VOD can see it too. And then I will, you know what? Let's just upload it. Let's just upload it. I'm just going to add it now. I'm just going to add it now, and I'm going to say like TBD or, you know, work in progress or something. So Pulumi resource libraries. JSX goal TBD. We'll say resolution TBD. Create topic. Possible resolution. Cool. Okay. So here you go, chat. I'll create this one for you as well. I don't really know exactly, you know, again, where this is gonna, like, I'm gonna have to go back and edit it and change it and stuff, but you can at least have a link to it. So if you need, do this, go here, and we will do this. Resource libraries, boop, 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 boop. Okay, there you go, chat. It's all you. You have all of the power and everything you need. Go forth and build stuff, whatever. All right, guys, thank you so much for being here. I really appreciate it. Again, if you are new to our community, thank you so much for hanging out with me today. I really appreciate it. We are a co-hosted stream by myself, BG, as well as my good, wonderful friend Atoda. I basically code on the stream. Atoda plays video games. We also do co-hosted streams together where we do IRL content. We'll play games together. We are working actually on something that we're really excited about. We've been spending a lot of time. If you check out our last stream notes, so the ones from the last stream, you will see that we actually talked about our new streaming setup. You're welcome to check that out as well. But we were testing our setup as well as doing some tweaks to it for party mode, which is something that we've been really excited about bringing back for a while now. But that's when me and Atoda both play games on stream together. And actually, I can show you a quick preview of that if you're interested. There's a complete article on how we set up our whole stream setup. It's called Low Latency, High Quality Live Streaming Setup. If you scroll down, you can see that this is, the workflow. We've got all that stuff available to you. But essentially, doing all of that enabled us to be able to do stuff like this, where Atoda and I can play side by side now on stream. The latency is incredibly low. The quality is incredibly high. We're able to switch through scenes really well and effectively. Here's where we're watching Atoda for a second. And then I think at some point here, it'll probably switch back over to me and Atoda. But this is a whole experience that we've been building, working on for quite some time now. And all of that is documented in here as well. And so party mode is something that we're working on bringing you guys, and hopefully, hopefully you guys like it. So again, thank you so much. If you want to check out our fantastic community, you're welcome to be a part of our Discord. Feel free to join it, ask questions, be a part of the conversation, whatever you want. We'd love to have you. Also, our social media. So a couple things about the social media. First thing is our new YouTube channel. This is a channel that we are going to be growing more and more. If you go to the channel right now, you will see a playlist on our migration cloud, our Microsoft Azure cloud migration series. This is a series that we did with them, so it's actually on their channel, but at least we were able to set up a playlist for it. It was part of the agreement, so it's totally fine with us. It's awesome, and the exposure has been awesome so far. So it's something we really are excited about, but it's something we still want to share with you guys. So be sure to check out that YouTube channel for that, as well as a bunch of other stuff we're going to be putting out. On top of that, there is a new YouTube channel that I'm creating called the Alta 4 Archives. And this will basically be where all of our VODs go and anything else that isn't really like main YouTube content and stuff. I don't have a link for that yet because I'm still working on getting that up and running. But it will be in our channels section. I think if you go here, we'll feature it in our channel section on our YouTube. So don't worry, it'll also be a part of our links later on. I just wanted to let you know that you will be able to access all of our VODs for the long term. The VODs will always be available in the wiki, but they will be removed from Twitch at some point and be migrated over to YouTube because Twitch doesn't keep our VODs forever. Womp. All right, guys, thank you so much. Again, I really appreciate it. Again, be sure to check out the Discord. Check out our YouTube, check out our social media, all that good stuff. Thank you guys so much again for hanging out with me today. Really, 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 really appreciate it. I hope you guys were able to at least leave with something new, something interesting, and something that you can take, with yourself for your next DevOps deployment adventure. So let's see who we can raid. I'm not normally on at this time, so I don't know many people, to be honest. Learning Tailwind CSS. Oh, interesting. Don't know who that is. Let's see what this person is up to. Give me 1 second, guys. Well, I don't really know anybody who's online right now, like at all. I know one person we can go raid, but I don't really know if she's like actually working right now or if she's just hanging out. She's in just chatting. She's normally working on cool robotic stuff and all sorts of stuff, but I'm trying to see if there's anybody new we could raid. Is there anybody doing DevOps? Nobody ever doing DevOps. Website, first time streaming. Wow, this category is completely dead. All right, let's just go raid Danny. Let's go give Danny some love. So Danny is a fantastic streamer. If you don't know her, she works on a lot of more like robot. Wait, what is this? API stuff. Oh, wait a minute. That's okay. Let's just go raid Danny. We'll go raid Danny. I can't hear their stream, so I don't know if it's like good or not. We'll raid somebody else later. Again, this is not normally our normal time slot, so I don't normally know who's online right now. But Danny is actually, and she's an awesome streamer. If you don't know her, she works in robotics. She likes to do a lot of really cool, interesting builds with, she has a 3D printer where she builds a lot of different stuff and then she programs it. And she's currently working on a really cool project that I found really interesting. It's a whole like smokers, like helper thing with like an arm that knows how to like light a lighter and like everything. It's really cool. I really like it a lot. So let's go raid Danny, say hello, enjoy the rest of your evening, guys. I will be back Monday for more streaming, if not probably Tuesday as well. The schedule's been kind of all over the place, but thank you guys for dealing with it. And like I said, we'll always be here. I just don't know if it's gonna be Monday or Tuesday of next week. Always check the Discord, always check the social. That's when we always post when we're going live. So thank you. Have a fantastic rest of your evening. That's a Toda. Go enjoy Danny's stream and have a good rest of your weekend. See you guys. Bye.